Okay, we understood what is the state transition probability. That means at a time t, I'm state I at a state I. At a time t plus 1, that means if I discretize this time, okay, so we are talking about the discrete HMM, in continuous also we can extend it. So at time t, at a day, any time instant, I'm at a state I. So in the next time, t plus 1, what is the probability? I will be in state j. That is represented by Aij. How many such Aijs? Such Aij will be n cross n, because n number of states. So this is n cross n matrix. So next is matrix B. Okay, the observation symbol probability distribution matrix. What is it mean? Given in state j, what is the probability that I am producing such a symbol? Okay. That means if I say one example, as I told, I'm sitting here, I can do many things. What is the probability that I am teaching? That produce a symbol in a state, it is producing that symbol. Given in a state, okay, this is the state T, I am producing the word book. Okay, that is the probability. So BJK, so how many such distinct symbol sequences? M symbol sequences and n number of states. Okay. I can produce that symbol sequence in any state. What is the probability that in state J at a time t I am producing that symbol? So it is a n cross m matrix. And the initial probability vector, that is the third thing, since it is the sequential information, it is modeling the sequential information from where I will start. Okay. Suppose there is a novel. Okay. I am reading from line number 3. That means this is the initial probability. So if I am reading this word, so what is the probability of next one? So that type of thing, pi I is the initial, from where I will start. From where I will start. Okay. From where I will start. So the HMM model, if I'll say, if someone give me A, B and pi, it will completely describe the HMM. So these are the three parameters. Just like yesterday class, that K means algorithm we have discussed. K mean means that mean vector, if someone give me this number of means, that means K number of means that represent the model. If I will model through a Gaussian, if someone give me a mean and variance, it is the model. Similarly here in HMM, I need three parameters. One is A, this is the state transition probability matrix, and B is the observation symbol probability distribution B, and pi is the initial model from where I will start with. These three things, if someone will give me, then it will completely describe the things. So what are the problems in HMM? There will be three problems in HMM. Okay. The first problem is the recognition problem. Recognition problem means I have a lambda, that means model A, B, and pi. These things are with me. How efficiently, given an observation, how efficiently I can compute Px given lambda. That is nothing. This is the maximum likelihood computation. Okay. So what is the state sequence that describes best this observation sequence? X1, X2, Xt are some states, Q1, Q2, Q3 are the states. Which are the states that represent this sequential information? X1, X2, X3. These are sequential information. That means X1 is the first observation, then X2 should be second observation. It is sequential information. I cannot cut some information in between. Okay, it will model the sequential information, but in the K-mini clustering or GMM, we don't need this sequential information. How one data is aligned to the next data. Okay, so if I write a equation for that, so let's say the first state is Q1, so that means I will start, just to get a feel, Q1, pi Q1, that is the first state is Q1. From Q1 state I have started. Being in Q1, I have produced the first observation X1. Next, what I have done? Q1 to Q2, I have jumped. Then there I have produced a symbol X2. Then Q2 to Q3, I have jumped. I have produced some symbol Q3 and so on, so on. Okay, this is the thing. But this is one possible sequence. This is one possible sequence. If I will just change one sequence from Q1 to, if I will jump to Q3, then everything will change. Then everything will be changed. It does not mean that Q1 I will produce, X1 I will produce in Q1, X2 I will produce in Q2, XT and QT. I can, one state I can change. One jump I can change. So everything will change. So what I have to do? I have to compute all such possible combination. How many such public computation? If I'll do each state, one state I'll change and I'll find this total probability. If this probability for which sequence that probability is best, that is my possible state sequence. But how can I do? If I'll do such a computation, I will take 2t and to the power t computation. So which is not possible. Given one state or two state, two observation I can compute on my hand, given a 1,000 or 5,000 of observations, so it is not possible. So we have to efficiently do this. How we have to do efficiently. So this is one problem. Second problem, given the observation symbols, so how will model these parameters? That is the second problem. And the third problem is how many states I have to take. How many states I have to consider to design my HM. That is the third problem. This is the designing problem. Someone will say I will design only using 20 states. Someone will say I will design with 200 states. Okay. So this is the first problem. I'll see how efficiently, this is the recognition problem, how efficiently I can compute this Px given lambda. That is the thing. Okay. We have started from this. My objective is I have to find P lambda given x, but using base rule and all, we have solved this problem. And we told if I'll compute this thing and I have a language model, I can do this. So how we'll do it? We can do it, such a problem, such type of problems, we used to compute through recursion. So how we'll do that recursion? We'll define. So we'll just define few variables. Okay? Then we'll try to put the recursion. Recursion means given the first state, what is the next? If given next, what is the third? Like that. That recursion we'll do. Okay. So it is the forward variable. It is the forward recursion. We can also do backward recursion. There are two types of recursion. One is forward, one is backward. So this forward recursion, if I'll do, so I'll define a forward variable alpha ti. Okay. I'll read it. Probability of x1, x2, xt minus 1, xt, qt is equal to I lambda. How I'll read it? I'll read it like that. I'm producing some symbol. At time t, what is the probability that I will be in state I? I'll be the probability at state I. Throughout the day, I'm roaming here and there. At the evening, what is the probability? I'll be in my home. That qt is equal to I in state I. This is why we can probability of producing q1, q2, qxt and ending at state I. I can move anywhere, but at time t, I should end at some particular state, that is the I, and what is that probability? That is nothing, alpha ti. Okay. No matter how I have produced, दिन भर में कहाँ गया, I have roamed here and there, as I told, that is immaterial. But at the time t, at the evening, I should be in my home at state I. So probability of producing xt and ending at state I at time t for the given model. Okay, this model is given me. I'm just discussing further recognition problem. So how x2 and x3 are produced? It is immaterial, as I told. So that alpha ti, that I am writing q1, q2, qt minus 1, because how I have produced q1, q2, q3 up to this state where I have jumped and that is immaterial. So in the first initialization, if I'll do, where I will be? Initial, I have to start somewhere. That means q1 is equal to I. That state q1 is equal to, this is the first transition I have started from I. How many such i's? Such i's are n number of i's. I can start from somewhere. Suppose I am saying at the evening I will my home. So from the very beginning I may be started from my village very morning. I can at the very morning I may be at some cinema hall or somewhere. So that how many possible ways I can be start? There are n number of ways I can start. Okay, मैं बोलूंगा 3 बजे मेरा ऑफिस में होगा, सुबह में कहाँ था वो मैटर नहीं. देयर आर n possible ways मैं रह सकता हूँ. That means one possible way is q1 is equal to I. So that means I will write p pi I, that means the initial probability in I, pi x1. That I is equal to 1 to n. That n number of ways I can. Then I will do a recursion in the next state. Suppose at q1 I will be 1. At the q2 where I will go? That I can do the recursion. So I am writing in general ways. Alpha t, it is given. So alpha t plus 1, x1, x2, x3. At the next state, I will be at state j. I will be at state j. So what I can write that recursion? Alpha ti. Next state means I have to make a transition, state transition. Aij, that is one transition. And in the state j, I can produce a symbol. That observation. Okay. What is the t? T is equal to 1 to t minus 1. Why? Because in the last state, last observation, there is no transition possible. I'm giving 100 observations, so up to 99 you can jump somewhere, but at the end where you will jump, you cannot jump. So it will be t minus 1. You understood this thing, this recursion. Okay. So now I can write the final recursion, that t number of observation I told. So x1, x2, x3, that we can write this recursion. So this is nothing, this computation is reduced like anything. So we have started from one state. So I can compute over the next state, next to second state, then third state, fourth state, that recursion I can compute. So finally, every observation will be end. So I will have some observation. That means I have done a mistake. I have not done any graph. Finally, we'll see. So when we'll search this Viterbi algorithm and all. So we are here. I can jump anywhere. So I will jump here. That is the best probability. Then from there I can move anywhere. So I will find out the best. From there I can move anywhere. I will find the best. Then finally I will conclude all these probabilities, and that is the best path. Best state sequence. So state sequence means that is a word. So given observation, I will find out what is the corresponding word sequence. Okay. This is the forward recursion. In similar fashion, I can do also backward recursion. Backward recursion means I am starting from somewhere, I'm ending somewhere in the forward recursion. In the backward recursion, I'm ending somewhere. From there, I will backtrack. So I can start from where I have started. दिन भर में कुछ घुमा रहा, that example I'm saying. At the end, I am at my home. So I can track next 1 hour के पीछे कहाँ था, next 1 hour पीछे कहाँ था, next 1 hour पीछे कहाँ था, next 1 hour पीछे. So if I'll track like that, I'll be find out what is my initial state. So that is the backward recursion. Okay. This is the forward recursion, what we have discussed. So this is the backward recursion. So here what I'll do, I'll define the backward recursion like that. Beta t, we are giving just one symbol, beta t I, that means state I. So probability of xt1, x2, xt given at a time t, I am at some state I. At time t, I am at some state I, and the model parameter lambda. What is the probability of next sequences? xt1, x2, xt. Okay, so it is just reverse of that. So how will I read it? Probability of producing remaining observation symbols. That means observation. That means I am writing I am book. I, I am taking. So I can say I am taking this book. I am taking your mobile phone. So that means remaining states taking if it is given. So what are the next step? Observation symbol sequences. That is the observations. Probability producing remaining observation symbol sequence. That is xt1. That time t1, time t2, time t3, up to time t number of observation. As I told, given the fact we are in a state I at some time in between some state. So initialization beta ti is equal to 1. Why I am writing beta ti is equal to 1? This capital T means it is the final observation. It is the final observation. Okay. So it will have probability 1 because we know that observation there is nothing to produce. Beta T is equal to T number of observation. Capital T means it's the final observation. If the final observation is at I, there is nothing to produce. So it will be probability 1. So at time T, we are state I, there is no symbol to produce. Final symbol we have produced. Then what we have to do? We have a backtrack. That means final observation is T state. Observation the next previous observation T minus 1. Then previous to that is T minus 2, T up to 1, the first observation. So I can write it Aij. Aij, why I am writing every time? Aij means given at state I at time T. So next will be Aij, any recursion. Aij, that is the probability of jumping to any state j. How many such j's? N number of j's. How many such i's? N number of i's. So it is beta t plus 1 because beta t. So next state, whatever, beta j. And in that state j, I will produce a particular symbol x t plus 1. So that also we can put a recursion. Okay. So that we can also put a recursion, that is the backward recursion, and we can compute that. So this is the recognition problem. Recognition problem is that we have a HMA model. Someone develop HMA model, let's say, and he has handed over to me. The HMA model means I know all state transition probabilities, probability of one state to other. Everything is given to me. In that state, what is the probability of producing in particular state a symbol? That is also I know. And the third thing, the initial probability distribution. What is so? How many? This is a column vector pi I, n number of observations. So it is also given that. So every time I used to start from this observation. This starting up from this observation. For this sequence of observations, the probability of each state is given to. Okay. So these things, if I know, so once if someone will give me some observations, I have to arrange that observations such that the probability, the joint probability, that means the probability of this sequence of states is maximum. So once I will maximize that thing, I can do the things. In natural language processing problem, if I'll say there are some sequence of words, so how we used to write those sequence of words? What is the best way we used to write? So that is the problem. That problem we have seen how to do it. So now we'll take the next problem. So before taking the next problem, we'll try to understand few more variables or concepts. Okay. So first we'll zeta tij will define a new variable and we'll try to interpret it. In HMM there is nothing. You can write your own code if you understood the things. So how will define this thing? What is the probability that passing through a state I at time t and a state j at a time t plus 1? Okay. That means I am sitting here at time t, say 3:30 p.m. So what I will do in 4:30 p.m. That is only two sequence matter, two states matter. मैं 3:30 तक क्या कर रहा था, कहाँ कर रहा था, that is not required. And 4:30 के बाद मैं 5:30 को कहाँ जाऊंगा वो भी मुझे कुछ जरूरत नहीं. मैं अभी I'm taking this session. After that, what I'll do? Okay. So that is the thing. So I'll define zeta t ij. That means only matter of two states. That if I write mathematically, probability of qt is equal to I. At time t state is I, and time t plus 1 state is j. And the x lambda it is given means this observation is given to me and model parameter I know. Whenever we are modeling, this lambda is in our initial random numbers. Okay, so we are trying to upgrade that. So I can write this thing using this base rule PA given B is equal to PAB divided by PB, that you know this conditional probability. So I can write this X I am taking off. So QT, this joint probability I am writing, QT is equal to I, QT plus 1 J, and given this observation. Okay, this is the total probability. So I can write there are, how I'll define? There are many I, many J, n number of I, n number of J. At 3:30, I could have done many things, and 4:30, I could have many things. But in 3:30, I'm at this session, and 4:30, I'll be in my chamber. Okay, that is the possible states. So, extend that are all possible states. So, we have interpreted zeta ti, ij. That means at time t, I'll be in state I, time t plus 1, I'll be in state j. Okay. So, now we can write it using our forward and backward variable. At a time t, I am at I. That we have, in that way we have derived this alpha t. Alpha t means what is the probability that I am producing some symbol at the state I. At time t, I will be in state I. That's what I am saying here. Qt is equal to I. That means at time t, I will be in I. T plus 1, I will be j. So that means if I write x1, x2, xt is equal to I, then I have made a transition I to j, state j, and b, there I will produce a some symbol xt, then I am moving to some other state at qtj. So that if I'll I'll write alpha ti. This is the forward variable we have defined. Aij is the state transition. In that state, I am producing some sound. In that state, I am writing in natural language. If I'll say I'll writing some word, book, cook, move, something I am writing. BTJ, and next I will write something else. Okay. So beta T. So this is the things, and total things. Such ij's are n numbers. So this is the possible. So this is a particular case. I can be state I can be anywhere. At time t, I can be any state. T plus 1, I can be any state. I have n number of freedoms. Okay. So this is the total probability. I, j, n is given. Given x and lambda, we can calculate this probability. We have seen this alpha t, beta t, we have defined. We can always compute this. Okay. Okay, we'll just we'll relax this thing. I will not say in state time t I'll go to j. So I'll just only say what is the probability that I'll be in state I at a time t. State I in time t means I'm relaxing this part. If I'll relax this part, so only so zeta t ij. Okay, so I can go move to any state. Okay, so I can write gamma ti, that is one particular state. Qt is equal to I. It is slightly different from alpha ti. Okay, only I'm saying one state. Okay, so it is sum over j why I am writing. You can understand this. There are j number of states. I'm not considering anything. So zeta t I j means all possible states. Suppose I will say I will just that example. I'm taking this class now. Next time I will be in chamber. That next time I will remove. So next time it is relaxed. So I can go anywhere. Okay, so there are n number of possible things I can do in the next state. So therefore I am writing zeta t I. So no restriction on the next state, that is clearly written here. So it is alpha t, beta ti, that state relaxation we have done. So now we'll say, given this sequence of words, expected number of transition from a state I, that we have to understand. Suppose there is a word like something, you will say pen. So I am using so many words, so many words. So how many times I am writing that word? Okay, that means expected of number of transition from a state I. Given a state I, how many times I am moving through this state. ओके, मैं घर से आया, ऑफिस को आया, बीच में मेरा मेन बिल्डिंग है, ओके। सो मैं एक बार घर को खाने के लिए आया, ऑफिस को आया, फिर रिटर्न गया घर, उसी रास्ते में मेन बिल्डिंग को क्रॉस कर गया, फिर आया, फिर गया। मैं बीच में क्या कर रहा हूँ उसको मैंने बोला कितना बार टाइम मैं मेन बिल्डिंग को क्रॉस कर रहा हूँ। दैट इज द थिंग, एक्सपेक्टेड नंबर ऑफ ट्रांजिशन फ्रॉम स्टेट आई गिवन ए एक्स एंड लैम्बडा. That means this variable we have defined. Okay. कौन सा टाइम में क्रॉस किया, दैट इज इमैटेरियल. इफ आई विल फिक्स दैट एट 2:30 आई विल क्रॉस द बिल्डिंग, दैट इज समथिंग. बट आई विल से कितना बार किया, मैं 10 बजे 10 बार कर दिया कि 5 बजे किया, उसको कुछ महीना नहीं रखता है. सो दैट मीन्स expected number of transition, we have relaxed that thing, that what time we have done. How many time means t is the observation. How many such observations? T number of observations. But here I am writing t minus 1 because the last transition, once I reach somewhere, there is no way to make a transition. मैं एक बार घर में पहुंच गया, रात को सो गया और मेन बिल्डिंग को आऊंगा नहीं. That means t, that t last observation, there is no chance of jump. So that means this many times. Only here I have written q that time t is equal to I. Here I am relaxing that time. So gamma t. Similarly, I can write probability of transition from state I to j, that zeta tij. If I relax that time, zeta tij, here I have written at a time ti, at a time t plus 1 j. If I say remove what time may be, time का कुछ matter नहीं करता है. So that means I will relax that time. So I have to take a sum over all times. Okay, probability of making transition from state I to j, no matter at what time the transition is made. कब ट्रांजिशन किया, मैं यहाँ से वहां गया, वहां से यहाँ, कब गया उसको मालूम नहीं. इफ आई फिक्स द टाइम, इस टाइम में ये था, नेक्स्ट टाइम में ये करने का कितना बोल, दैट इज समथिंग एल्स. ओके, सो वी हैव टू सम ओवर ऑल द टाइम. Similarly, probability of in time in state I, no matter at what time, that gamma t we have defined. So it will be like that. If I relax the time, here I am writing t, probability of being in state I, there is no transition. So out of t number of observation, any time I can be in state I. So there is no question of transition here. But there is a question of transition here. Therefore, I am writing t minus 1. Last, there is no transition. So now, given a observation symbol sequence, that means given a observation, some words, how I will model this HMM parameters. So what we will do? Any machine learning problem, from where we'll start? We'll make some random numbers. We'll just make some random numbers. We'll first plug the random numbers, then given the data, these model parameters will be get updated depending on the data through maximum likelihood estimation, as I told, MLE, maximum likelihood estimation. Okay. But in this case, random numbers, we cannot fit any random numbers. We have to follow the probability constants. The probability constants. That means pi I sum over all pi I is equal to 1. That means total probability is 1. There are n number of states. I can start from any state. So if it is equiprobable, I'll say initially I will say it is equiprobable. I don't know from where I used to start. So I will, equiprobable means 1 by n. Each state have equal probability. Or otherwise I can plug some fractional random numbers, and the constant is that if I'll sum all these things, it should be 1. Similarly, for all ij, sum over aij is equal to 1. That means from a given a state I can jump to anywhere, n number of states. Okay. So that means if I sum it, it should be 1. And BK, that also given in state, I can produce any, given a pen and paper, I can write anything. But what is the probability that I'm writing this particular word, particular thing? So that should be 1. So what I'll do, given these random numbers, I have to update my model parameters. Given these observations, I have to model. First, we will try to update in the first iteration, I number of iteration I will take, some n number of iterations I will take. So how will you update this parameter? Pi I. What is pi I? Pi I is the initial probability. What is gamma Ti? We have defined gamma Ti is the probability that at time t, I will be in state I. I is n. This pi I representing the pi which state, from which state I am starting. So gamma 1 I means it is the state at time t, gamma Ti we have defined. Now t is 1. This is the first instant, gamma 1 I. So I can write it. I know how to compute this gamma Ti, where it is. Gamma Ti, we have written this, defined this. So I can use that relation to find out this gamma 1 I. So probability of being in state I at time 1. That is first. From there I will start my step, the initial probability. Okay, alpha ij, it is this transition from I to j. I'm not putting any time. What is the probability? If I will be there at the NIT mode, I may take a snacks, I may there I can go to Gandhi Maidan, I can go anywhere, but not I'm mentioning any time. So what is the probability? Given a state, I can jump anywhere. Okay. So that means that we have defined. If I relax the time, that thing we have defined here. So I can write alpha ij. That means a particular transition divided by total number of transition. Ratio of expected number of transition from state I to state j to the expect of a transition from I. Given a state I, next state I can go anywhere, but I'm fixing one state. Given a state this, next I will go to this state. Okay. So ij divided by total possible that we have defined. So we can learn this thing, we can update giving the data. On that data, these random parameters will be get that easily it can be calculated. Okay. So that we seen. So I'll be in a state j. What is the probability of producing a particular observation? Okay, that means you have to interpret properly. I'm sitting here in one state. I can do many things here. What is the probability that I'm teaching? That is the thing. So I can be in that state and producing a symbol. That means producing this observation. Observation is some task we are performing. That is the observation. We are observing that thing. That observation. Okay, we can easily model the parameters. Okay. So we have understood what is the second problem in HMM, how to develop these models and all. The third problem is to find the state sequences that describe the observation symbol sequences. That is the Viterbi algorithm. What is the state sequence that best describe the observation symbol sequence for a given lambda? Lambda means this model we have. Okay. What is the state sequence? What are the particular states for this observation? That joint value we have discussed in the very first. So how many such state sequences given observation? Given the observation, this x1 may correspond to t1, q1, x2 may be q2, x3 may be q3, or x1 may be q3, x2 may be q4, t may be xp something. Okay. So how many such t number of observation if you put T number of observations this horizontally, N number of states. Okay. So how many such possible combinations? Is N to the T probability or state sequences. For a given observation, T number of observations, if I have N number of states, so there will be N to the power T probabilities or state sequences. What is my objective? I have to find out the best state sequence that describe this observation symbol sequences. I have a state sequence, observation symbol sequence. I have to write the state sequences. So if I will solve, someone will say I will compute all these possibilities, permutation combination and find the best. Okay, you can do it. But in a digital computer, if you try to do it for one iteration, it will take 1 year. Okay, so it is not possible. And one efficient approach to solve this problem is the vector B algorithm. Okay, vector B search. If you know natural language processing and all, you should encounter with the vector B algorithm. So argument maximum means that I told that indexes, we have a grid. I have to find out the indexes. Okay, that maximizes this probability. That maximizes this joint probability. That grid I have to find out. What is the path? That grid I have to find out. Therefore, I have writing argument index. That index, those indexes which maximizes this joint probability. So we can do it. If I will define a variable, just we are giving some notation. Delta Ti. Okay. How will you read it? Probability of Q x1, x2, xt at time t, I will get I. If I will compare that forward variable, what we have written, probability of x1, x2, xt minus 1 t at time t is equal to I. Okay. Here just a slight change. Okay. Okay. So I can do a initialization delta 1t, that means the first thing, delta 1, that means first, it is the maximum of px1 q1, that means in state I will produce the first symbol x1. State I means what is that probability? I should be in state I, that probability is pi I, we have discussed, and being in state I am producing bix, that particular symbol, that observation. This is the initial condition. This is the first. Then we can write a recursion. Then Then the next step, I can write t plus 1 j. What I'll do? That means that state which maximizes this probability, qt is equal to I. Okay. Okay, we understood what is q1I. That means you think t is equal to 1, then the next state, maximum delta t is the initial thing. Okay. Then I am making a transition I to j. Okay. Then in the second, I will produce some symbol xt. T. So that t is equal to t to t minus 1, that I know. The last there is no transition, so I am writing 1 to t. J is equal to 1 to n number of transitions. So what is my objective? My objective, as I told, I have to find out the argument maximum. That means those indexes, those at time t, I have to note down the states, and that state, that sequence is my state sequence. That is, it is some matrix that is preserving these indexes. I can write argument maximum, this thing. Okay. So we can see it through a search algorithm. As I told, there are t number of observations, time, that means some observation x1, x2, x3. There are t number of observations. I have some n number of states. Some n number of states. So what I have to do? I can start one of them, that depending on the pi I, which have maximum probability, I will put my cursor there. So let's say 2 number have maximum probability. Being in 2, I can jump to anywhere. I can go from 2 to this, 2 to 2, 2 to 3, 1, 2 to 3, 2 to 4, 2 to n. N number of ways I can. So I'll come to any state. Okay. You can do in that way. Otherwise, I am in state I, okay, J. I can move from anywhere. I can move from this to this, this to this, this to this, this to this, like that. Okay. So from where I have started, that depends in this probability. Which one have maximum probability, I could have started from that. So given the next, to this state, I can move from this to this, this to this, this to this, this to this. कहाँ पे आता है वो? So I have to now track the path. First, let's say I'm here. So I have to find out from where I have started. If I'm there, from where I have started. If I'm here, from where I have started. Here I am, from where I started. So that is the path. And if I multiply those probabilities, that is the probability of that word sequence. So which sequence I will consider? I will consider that path, okay, for which the probability is maximum. It is very similar to dynamic time working. It is just, you can view, it is a extension of dynamic programming. Dynamic time programming, I think you know, that also model the sequential information. There are many ways you can model the HMM, as I told in the very first slide. Okay, so if you will increase that interconnection and all, that will increase your computational complexity. Of course, if you link that thing every state to every state, if you, there is n number of freedoms, that can be. So this IBM people, they used to, hello, I'll take this question. I'll take this question. Just let me complete this slide. Okay, so in this Becky's model, this IBM people, they used to do this. Okay, only forward direction. Okay, so that means this Aij, if I write, this upper diagonal are non-zero. If it is fully connected, then forward to backward, backward to those things, that will be this thing. Okay, so this is the thing. We can say j less than I, that mathematically if you write, that means there is no way it can come backward. In ASR also, this speech audio processing and all, okay, we used to use this forward. Only the forward path is allowed. Given a state time t, I will state I can move to the forward state. I cannot come back, because that is some problem that I am not discussing. This phoneme sequence we are writing, that is not permitted here. But in language person, I don't know. You can connect also forward backward. Okay, in reverse way also. System training, as I told, given some observations. Okay, we can, one word you can model with 3-state HMM. So, suppose for ASR we used to use 3-state HMM. For emotion recognition or for some medical analysis we used to use 7-state, 8-state HMM. Okay, so one state you can, this 7-state model you can connect with another 7-state, another state, that sequential information we can model. Okay, for a speech, so we used to model a phoneme, the sound unit. That sound unit we used to concatenate to make a word. Suppose for language, natural language, you can model one word, then you can connect to the next word, like that. Okay, so take that T one sound, we are modeling with 3-state. A, that is another sound, we are modeling 3. K, we are modeling 3 sound. Like that, we are concatenating to make some meaningful words. Likewise, someone may model some words and concatenate it to make a meaningful sentence. Okay, so depending on the applications, we can use it. And the recognition problem, as I told, so we have a n-gram language model or a network. Network means nowadays people are using this neural network trained language, pre-trained language models. Therefore, I wrote network. And some pronunciation dictionary, that how we used to break these things in a certain type of task. and this phoneme models in speech or word model in your case, okay, we have to decode it and we have to make it some meaningful. This is the end slide. Okay, thank you. You can ask now.
Hello, sir.
Okay.
Now, in this case, suppose I apply this to the sentence in a language, then do you mean here you are considering the observation? So, observation is a word or sentence or a character?
But that depends. For a speech case, I know it is a character. Okay. As I
Okay.
discussed with sir, for your case, it is a word. Observation is a word,
Yeah,
no?
it should be
Word
word
or a
in case of,
character.
Sentences depending on the scenario you are trying to model this.
means even a character can be a observation.
Yes.
Okay. Yeah, okay. But suppose dictionary, this, as I know,
Like even in words also, say if we want autocorrect feature you have seen in mobile phones.
Yes, yes. Yeah.
There the words are considered to be an observation. Then only you can correct them,
Okay.
no?
Okay. In
Okay.
dictionary search and all, they used to consider the character as a one observation. Suppose if you write 2, 3 character, then it will suggesting that the next character is like that. This is Microsoft word and all.
So that reverse uh, pass and in forward pass usually we see so reverse pass is applicable in that case, that correction you just told, is it, sir?
Reverse means that depends on the application. For my application, I used to only forward path. Okay. For suppose dictionary, you are correcting some dictionary, then why reverse path is required? Only
For
forward
that
path is
auto
required.
correction then it's how it is applicable?
Only forward path.
Using forward path only.
Only
Forward.
forward
If
pass.
dictionary, how there? If I write B, then there are maybe how many 49 phonemes, some many characters possible. If I write 2, that possibility will reduce. Okay. B O
Okay.
लिखा है मतलब that maybe B next O. Okay. कि कुछ होगा,
Yeah.
आई हैव टू बी ओ लिखा है मतलब बोर्ड भी हो सकता है, बी ओ ए टी हो
Yeah.
सकता है.
Yeah, that's what I want to means ask ki that reverse is not applicable to in case of a word, is it true?
So it's we cannot say that it is not applicable. It depends on scenario. So the application model what you are using for your applications, you may require some sort of reverse cases also.
Okay,
But
thank
that
you.
depends on the application, purely on the application.
Okay, and one more query. You have used that lambda in the notation while explaining Viterbi. So, what is that lambda? That is not clear to me.
Lambda is the model parameter that transition probability, observation probability matrix, and this initial probability. That is the model parameter. As I told, for a
Will you
VQ
please
vector quantization, I
switch
will
to
say.
that PPT that where that lambda is
Yes,
written?
yes.
That will
Lambda
say.
is written. Yeah.
Lambda is the model.
Can
Not
you
clear, means not clear. Lambda is model. Backwards it was given.
Okay, I'll
Yeah. I mean, some doubt I have about Viterbi
okay,
model.
madam. Slide नहीं जा रहा है. पीछे नहीं जा रहा है. Okay, madam.
This one.
Okay, everywhere it is written
Yeah.
that I'll go to the first, very first where it is mentioned.
Yeah.
So this is the lambda. Suppose if I'll ask you, madam, suppose let's say I'm saying a vector quantizer k-mean clustering algorithm. What should be the lambda?
Model means K means clustering. Initial numbers in the cluster.
Not initial numbers is not the model. Model is the means. That k means you are taking.
Centroid then.
Okay, centroid. That means centroid. Okay.
Yeah.
If I'll say Gaussian, what should be the lambda?
That
Lambda should be
pi.
some mean vectors and
Pi.
some covariance matrix, or you can say variance. Okay, this is the lambda. If instead of giving the complete data, 10 hours of data, if I'll give such parameters, it is suffices your problem. Okay, that is the model. So now, For the present case, what should I need? I need a state transition matrix. That means what is the probability of giving in state I, next state will be in J, that type of thing. There are n number of possible combinations. That is the
Yes.
state transition probability. That parameter I need. When I talk about HMM, I should know these state transition probabilities.
Okay.
Given in state I, what I can produce, as I told, I am sitting here, I can do many things. What I am doing, that is the given in state. Okay, what is the symbol? That is the observation I am producing. That is the B. That I should know. Okay, the observation symbol probability distribution. That means given in state J, what is the probability that I am producing I am doing a particular task, or I am writing a particular word. Okay, that I should know. And from where I will start? It is a sequential information, na?
Yes.
Okay. दैट मीन्स सपोज लेट से हम लोग अगर बचपन में इंग्लिश मीडियम बढ़िया से इंग्लिश मीडियम स्कूल में पढ़ते तो आज भी हमारा कुछ चेंज होता है। ओके, लेकिन मैं भी पॉसिबल नहीं होता, क्योंकि सपोज ये इतना पीछे हो गया, आज की डेट में उसका कुछ इम्पैक्ट नहीं है। मैं भी गांव में पढ़ के आया हूँ, सपोज लेट से। ओके, वो आज की डेट में मेरा उसके ऊपर कुछ डिपेंड करता है नहीं करता है। लेकिन मैं अगर +2 जाता तो ठीक है, 10th में पढ़ा हूँ तो वो दैट initial probability vector, that probability from where I have started, मैं कहाँ से पैदा हुआ, क्या हुआ, that sequence information is also carrying some information, that phi from initial state from where I have started, मैं first word क्या लिखा, उसके बाद next word क्या लिखूंगा, that probability, initial probability, that also carries, because it is a sequential information. In GMM VQ there is no sequence information. आप एक ऑब्जर्वेशन किया, नेक्स्ट किसको लिया, इसको लिया कि उसको लिया, उसको कुछ मॉडल के ऊपर कुछ इफेक्ट नहीं डालेगा। लेकिन इट इज ए सीक्वेंशियल इन्फॉर्मेशन, ये स्टेट क्या होगा तो नेक्स्ट स्टेट उसी अकॉर्डिंगली होगा। तो दैट पाई आई द इनिशियल, दैट इज द लैम्ब्डा, लैम्ब्डा इज द मॉडल। इस 3 पैरामीटर्स, जैसे जीएमएम में आप बोले कि 2 पैरामीटर है, VQ में 1 पैरामीटर है। मैं अगर बोलूंगा गॉसियन मिक्सचर मॉडल, उसमें और एक पैरामीटर है वेट, किसी गॉसियन को क्या वेट दूंगा, वेटिंग ऑल्सो, दैट इज ऑल्सो पैरामीटर। जैसे मैं न्यूरल नेटवर्क बोलूंगा तो उसका वेट वेक्टर्स are the model parameters. Similarly in HMM,
Yes.
okay, these are the model. Now I think you have understood. Okay.
Yeah, sir. Thank you.
Okay.
Hello? Thank you. Now we'll move on. So, would you want to have a break of 5 minutes and then I should start, or should I start?
Take a 5 minutes, 10 minutes.
Can start.
Okay.
Can start, but one more query.
Sir,
about
I had
the
a
last
query.
model. Can I ask, sir?
5 minutes break, sir.
Can I ask, sir?
Hello.
One query.
Yes.
Yeah, 5 minutes break.
So,
Yeah.
Yes, please ask.
Here again, one more thing is there, that if it is applicable to language, that is, say, if I consider sentence, and any state can be initial, as sir said, a random state. So usually in language models, anything cannot be a start state. Means that assumption is true again, or it is again applicable to a specific domain or
No,
specific
normally
situation.
say what sir told and what just I am reiterating, and I will also demonstrate you with an example, that if you read all the text of literacy work or say Wikipedia,
Yeah.
and if you just note down what are the first word which is occurring in a sentence,
Yeah.
just think over it. You went through all the literacy work of the world and went through all the Wikipedia text available on the net. That's what Google has already done. So if you go through that, if you
With
go
some
through
text,
that,
I will have to take as a starting text.
every word has got some probability of being at the start state, isn't it?
Yes.
And you can calculate that probability with the amount of text which is given. Might be that probability will be very small, might be 0.000002, something like that. Say the word D, it can have a higher probability, whereas say some name or some questions words, they can have lower probability, but they will have probability. And that probability is the phi, what the other sir was talking about.
Okay.
Okay, here also, madam, you have to take, that is, these problems are not very simple. Okay, suppose we are multiplying the probabilities. Okay, as sir told, If it is 0.5, 0.5, 0.05, 0.001, 0.002, if I multiply, finally where I land?
Means the usually we take which gives us maximum probability.
No, maximum means that probability we have to find that this is the state in the next state, this is the next state, to next state क्या होगा? That is some fractional number. If I multiply all, then where I land? I will end at 0.
So many
So
smaller
many
values. If you multiply so many smaller values,
fractional number.
they will reach towards zero only, no?
So how to solve it? That is also a
So
bigger
there are
challenge.
so many things,
Issues.
Okay.
internal details. In fact, while we calculate, like the scenario I gave you, you will have very small probabilities of each and every word. And then if you keep on if you have a longer sentence and if you just multiply every word's probability, the value will be very small,
Yeah.
right?
Yeah.
So how to tackle that and how to normalize it? There are so many other issues are there. But that
Okay.
this within, obviously you understand that within 1 hour or 2 hour, uh, everything cannot be covered. But at least
Yeah.
my idea is if some question is being asked by you, that means you are understanding or you are taking interest, and now you can find out the a lot of say answers to yourself also.
Yes. Yes. No.
And
Might
we
be
will be very
model little
happy
bit
to.
I was knowing.
Mhm.
So I was trying to identify how I can apply reverse. As I have seen, keep forwarding is mostly applicable in my application.
You will apply
So
reverse also, it will give good results. Okay, because that
okay.
error correction and all, it will be helpful. Okay.
Okay. Okay, sir.
Okay.
Thank
Okay,
you.
some other participant was also talking about some questions. So may I know who was talking about question, uh, has some doubt?
This type of hardware is required for speech computation. So, sir,
For speech or text?
for speech and text.
So basically for text, if you are just experimenting, if it is not a very industry oriented, the volume is manageable and even you can do it on your laptop also. But it is always advisable to have a server with a bigger RAM and GPU facility. With speech, the scenario is slightly different because speech data is voluminous. Even a 10 hour speech,
10 hours is normal. So you
uh,
have to train with model which is 70 hours, 80 hours.
70 hours, 80 hours, and that will take days to basically train the model. So in our lab with a GPU of around 5,000, say, processing element and one CPU and 512 GB RAM, it took 3-4 days sometimes to model that, to run that experiment. Okay.
Thank you, sir.
So,
Take a break 10 minutes बोले ना 10 मिनट break लेगा.
let us take a break of 5 minutes and then we'll assemble together and we'll discuss. I will give you just a practical example with pause tagging, exactly how all this, and then by that discussion, this HMM will be more clearer to you also. If you have small queries, that also will be resolved. So just bear with us.
Thank you, sir. Thank you, sir. Thank you very much.
A very good evening to all of you. I hope other people will also join in due course of time. As you can see that we are doing cryptography and cryptography. Last two lectures we have basically looked into some basics of mathematics that is required for learning cryptography and doing the cryptanalysis. Then we also started with the basic description of what is cryptography and what is ciphering techniques. And in the same pipeline, we have been talking about the various methods of doing so. So we will just continue with the same, and we'll just try to grab some more concepts related to that, so that when we are going to go for the mathematical cryptography, we should be able to perform the same. Last time I have discussed that there are different types of ciphering techniques, wherein we have got substitution ciphers, we have transposition ciphers, we have expansion ciphers, we have say compression ciphers, and there are many more kind of models.
Excuse me,
Just a minute.
can you switch on your video who is speaking? The next session will start within 5 minutes. Please wait. For the time being, if you have any question, you can ask me regarding what you have already discussed. Okay, so let me introduce Dr. Jyoti Prakash sir. Sir,
Yes, Bhaskar. Please continue.
yeah. So Dr. Jyoti Prakash Singh is an assistant professor in the Department of Computer Science and Engineering at NIT Patna. He has published more than 100 papers in quality conferences and journals. And he is also an co-investigator of a MIT-sponsored project called Spam Call Detection System. He is a senior member of IEEE and also has a long experience in working on NLP. So I welcome sir. Sir, sir, please continue this session.
So thank you, Bhaskar. I think my screen is visible.
Yes.
Okay, so I will continue from the point. I think I'm audible to you.
Yes, sir.
Hello?
Yes, we can hear you. We can hear you.
Powering on.
Am I audible to you?
Connected.
Yes, sir. We can hear you.
Hello, Bhaskar.
Yes. Yes. We can hear you, sir.
Okay. Thank you for confirming. Now, I will be just going to demonstrate you how the idea what Gadhar sir has presented, hidden markup model, how that can be used in part of speech. So before going into that mathematical details, the example, I will just briefly go through the part of speech, what a part of speech is. So why part of speech is? Because words that somehow behave alike appear in similar context, perform similar function in sentences, and undergo similar transformations. So words have these properties, and hence people have classified word in 9 different traditional classes of part of speech. Normally we read in it our grammar books, like noun, verb, adjective, preposition, adverb, article, interjection, pronoun, conjunction, and so on. So like some examples are shown here. A noun like chair, bandwidth, pacing, and this is represented by n. Okay, we can represent it by n. In my example, I will use this letter n for that. Verb, say study, debate, munch. These are the verbs. I will represent it by v. Then adjective like tall, purple, ridiculous. We will represent it by adj. Adverb, unfortunately, slowly. Pronoun, preposition of, by, to, and so on. So these are the different part of speech available in any text, any sentences. So pause tagging is in fact a first step towards the syntactic analysis, and which is often used for the semantic analysis. Yesterday, someone had asked what is syntactic analysis and semantic analysis. So syntactic analysis means checking that the sentence is following the correct grammar rule. So syntactic analysis, like if I say tree is flying, a tree is flying. So syntactically this is correct because tree is a noun, is flying is a verb. So syntactically it is correct, but we know that semantically it doesn't mean anything. So there are two parts: syntactic analysis, grammatically this is correct. Semantic analysis, that means it carries some meaning also. So pause tagging is a first step towards that syntactic analysis, that grammar checking. And normally we try to use a simpler model, which is often faster for than full parsing, and sometimes enough to be useful. Sometimes this pause tag becomes indispensable in case of, say, the sentiment analysis. So if we talk about sentiments, the sentiments are generally expressed by the help of adjective only, like good, bad, very bad. So adjective and adverb, these mainly tell about the sentiment of a word. So if we are going for sentiment analysis, then pause tagging is a the proper identifying proper pause tag, especially the adjectives, is going to be indispensable. And We will use, as I told, that hidden marker model will be used to demonstrate or basically used find out that tag with that. So pause tag, the process of assigning a part of speech or lexical class marker to each word in a corpus. So this is the target. So given certain words like this, which I have shown on the left hand side, and we have certain tags. So how to associate the tag with a particular, a word with a particular tag, this is the task. So we have two classes. One is the word, the other word is tag. So how this word, each word can be assigned to one tag. And in practical life, in fact, one word can have different tags. It can fall to, or it can be part of different part of speech tag, depending on the context it is appearing, that we'll see. So it is used in part of speech synthetic pronunciation, because in pronunciation, what Gather sir was trying to convince you that when we speak or when we hear something, we make a lot of we get a lot of disturbances, and then based on our own language model, we try to associate the represent the correct word. So there also we use this sort of tags or markup models. So let me just, since we do not have too much of time, I would like to highlight that there are two different types. One is called open class words. So English has 4 open class words like noun, verb, adjective, and adverb. And new words can be easily added here. It's a big class. And like these are the scenarios, then adjective, adverb. So this is one paint say tree bank. There are so many tag sets available in the for use by the linguistic those who are using in computer science. So this is one such, like coordination or conjunction word. They are represented by tag CC, cardinal number, that is represented by tag CD, DA. These are represented by DT, determiner, and then they are existential. So these are the different tags. For my demonstration, I will be using just a noun, verb, and adjective to explain that. Sir, class mein hai. So using pen tree bank tags, we can say tag a sentence like this. The, it can be a determiner. Grant, it is an adjective. Jury, it's a noun. Commented, verb. On, in. A, again determiner. Number is noun. Of is in. Others, again adjective. Topics, a noun, and so on. So now why the task is not so easy? The task is not so easy due to, as I told, that one word can have different tags depending on the scenario. Like if I say the back door, in this case, this word back is basically a noun. It is representing a back door. On my back, sorry, it's an adjective. Which door? It's back door. So it's an adjective. If I say on my back, then this back is noun. If I say win the voters back, then this is adverb basically. And promise to back the bill, this is the verb. So back has got the same word without any other addition or deletion, can be say put into all these 4 classes depending on the context this is appearing. So that's why this is not a one-to-one mapping. The mapping what I just demonstrated, it is not such a one-to-one mapping that, okay, we have one word and this will always go to this tag. Then the task would have been quite easier, quite simpler. So what is the real problem? The real problem, the pause tagging problem, is to determine the pause tag for a particular instance of a word. So pause tagging problem is to determine the pause tag for a particular instance of a word. So given one instance of word, what should be the proper pause tag for this scenario? It's hard as there are ambiguous. So like time flies like an arrow. Again, here we can have different tags associated with different words. So let me just, because I want to, so how we can make it? So there are some ways to do that. One is the rule-based tagging. but now hardly this is used. Transformation based tagging, again, this is very old technique and hardly it is used now. The last one, stochastic or probabilistic tagging, this is what is mostly used now. And this is used based on the hidden Markov model. And that's what we are basically interested in. So let's see an example. Let me just move on to that example. Okay, so let me stop here. Say we have this data set. Mary will see Jane. We have just 3 sentences. We are considering 3 sentences to explain this idea. So Mary will see Jane. Will see Mary. I'm sorry, this has just overlapped on this one. And Jane will see Will. So we have 3 sentences. Now manually, if we tag or if we see this, then this Mary will be noun. This will be basically a modal verb. See is a verb. Jane is again a noun, a name of a person. So these two are name of person and they are noun, definitely noun. This is a modal verb. This is not a name here. And this is a verb. Now here, will see Mary. Now this will is basically a name of a person. So this will be a noun. This will be a modal verb. See will be a verb and Mary will be a noun. Now Jane will see Mary, or say will. Jane will see Will. So here Jane is noun, will is modal verb, see is verb, and will is again noun. So given this information, now if I ask a question given another sentence, and if I have to find out what will be the tag for those sentences. So this is given to us. So this data is given to us. Jane can see Will. Spot will see Mary. Will Jane spot Mary. Mary will pat Spot. Say now this is the data set. Say we have. So if this is the data set, so the probability, if you think of how many probabilities Dr. Pradhan told you. So I will go with the first probability. So let's see. So this is the initial one. No, that probability I have not calculated. This is not coming. So okay, this one. So here we are calculating the pi. The first one was pi, isn't it? The initial probability. So how we are calculating the initial probability? So manually we have tagged them. Say Mary is noun. So look at the sentences again. Mary Jane can see Will. Spot will see Mary. Will Jane spot Mary. Mary will pat Spot. So let us calculate the pi first. The initial probability. Initial probability means Mary. So how many times Mary has come and how many times this was a noun? So this is what we are calculating. How many occurrences of Mary is there? That is of class noun. How many occurrences of Mary with class modal verb? How many occurrences of Mary with class verb? So if we see in the given sentences, Mary is noun here, and then Mary is noun here, Mary is noun here, Mary is noun here. So there are 4 occurrences of Mary and all are noun. So we can populate this with 4, count of 4 in noun. In modal verb, we cannot see any Mary. So it's 0. In verb also, we do not have any Mary. So it's 0. Now for Jane, so there is 1 occurrence of Jane here. There is 1 occurrence of Jane here and both are nouns. So again, this is 2, rest are 0. Will. Now let's see. Will is here. This is noun. Will is here. This is modal verb. So 1 noun, 1 modal verb, 2 modal verb, 3 modal verbs. So will has occurred or come at 3 places as modal verb and has come at 1 place as a noun. Spot. Again, spot here is noun. Spot is again a name here. Spot is again something to see. So here verb. and spot is noun. So 2 noun occurrences of spot, 1 verb occurrences of spot. So 2 noun, 1 verb. Modal is 0. Can. So can here is a modal verb. So just 1 occurrence as a modal verb. See. See here is a verb. A verb. So there are 2 occurrences of verb, nothing as noun or modal verb. Pat. Again, pat here is a verb, and that's the only occurrences. So similar, this way we can calculate the count, exact probability, exact count. And now we can calculate the probability based on this count. And this probability will be this. Because there were total 9 unique words. So 9, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, then 8, we'll have calculated. 5 is, there has to be 9. 1, 2, 3, 4, 5. Okay, 5. Then 6. And then 7. Sorry, 6. Then 7. 9. Total unique words, basically, we are calculating, no?
Noun में कितना total word है? Marry
Okay,
कितना है?
noun, total noun. Sorry. I'm sorry. So noun 1, 2, 3.
Left side हम लिखे हैं ना, उसको count करते हैं.
Okay, from here also we can calculate 6, 7 to 9. So there are total 9 words. So I'm really sorry that I was calculating the total word. It's the total noun occurrences. Out of total noun occurrences, the contribution of Mary is 4 by 4 out of 9. So we have calculated the probability in this fashion. So Mary is a noun. The probability is 4 by 9. We read it like that. Jane is a noun. The probability is 2 by 9. Will is noun, a probability of 1 by 9, and is a modal verb with a probability of 3 by 4. Spot is a noun, has a probability 2 by 9, and spot is a verb, has a probability 1 by 4. Then C is a verb, has a probability 1 by 2, and that you can calculate. So total verbs were 1, 2, 3, 4, whereas C was having count 2, so 2 by 4, so it will be 1 by 2, and this one 1 by 4. So that's what we have. So this is our pi, initial probability. What Dr. Pradhan explained you, I told you. So this is my initial probability. So initial probability means given this data set only, if I consider that this is my whole world, these 4 sentences are my whole world, then we can say that if I encounter a word marry, then chances of Mary being noun is 4 by 9. Chances of Jane being noun is 2 by 9, and so on. So that's what we can calculate from this. The next thing, so this is what I have represented. So say there is a generator called noun. So there is a probability distribution system, or there is a generator, noun generator, a machine which can generate nouns. So that machine will have 1, 2, 3, 4 options, because only 4 are non-zero. So this can generate a word Mary with a probability 4 by 9, Jane with a probability 2 by 9, Spot with a probability 1 by 9, and Will with a probability 2 by 9. I hope you are getting it. Similarly, with modal verb, we can have a generator which can generate just 2 words, because these 2 are only non-zero. So will and can, and then we can have verb which can generate spot, see, and pat. Sorry, this is not pat, this should be pat. Then the next thing is transition probability. Now we want to find out what is the chance that if I am in a verb, or basically I am in a verb and then, sorry, I am in a noun and then again I am going to another noun. So see here. So given this sentence, so there will be first probability that what is the probability that at start I will encounter a noun. What is the probability that at the beginning I will encounter a noun? So going from start state to noun. So this is what we write. So start state to noun. So the count is 3. You can see start state, then noun, start state, noun, start state modal. So this will not be considered. Start state to noun. So we have start state to noun. The probabilities are the count is 3. Start state to model, the count is 1. Start state to verb, 0 in this case. Start state to end, 0 in this case. Then noun to noun. So here we have noun to noun, and there is no other place where we have noun to noun. So noun to noun is 1. Noun to modal. So noun to modal 1, noun to modal 2, and then noun to modal 3. So 3 occurrences of noun to modal. Then noun to verb. I think noun to verb. And then noun to end. So noun to end, noun to end, noun to end, noun to end. So all 4 cases. Then modal to noun. So here we have modal to noun. So 1, modal to modal, there is nothing. Modal to verb. So I think modal to verb, modal to verb, modal to verb. So 3 occurrences. And modal to end, there is nothing. Then verb to noun. So here we have verb to noun, verb to noun, verb to noun, verb to noun. So 4 occurrences. Verb to modal, there is nothing. Verb to verb, there is nothing, and verb to end, there is nothing. So these are the count, and again we can convert them to probabilities by dividing them by the total occurrences. That there are how many cases where we have start to end. So there are 4, start to noun. So there are 4 cases, and so basically we are going in this way. So the total count is 4. So 3 by 4. This is 1 by 4. This is 1 by 4, 8, 9. So this is 1 by 9, 3 by 9, and so on we are calculating. So this is the transition probability. So if we represent, this is how it looks like. So given this noun, what is the probability that it will again generate a noun? That means it will go from noun to noun. So this you can see noun to noun. This is 1 by 9. So this is the probability. Then given a noun, what is the chance that I will next go to a verb? So that chance is 1 by 9. So noun to verb is 1 by 9. Noun to modal. So this one 1 by 4. So noun to modal is, this is noun to modal. This one. Noun to modal 1 by 3 and so on. So this whole transition, this is the transition probability. So now we have got 2 probabilities, the transition probability and the initial probability. Is it okay, Pradhanji? So then the next is we can now make a hidden Markov model like this, which looks like this. So what we can see this one. We can see a sentence and then we want to find out. So what we can observe, what is hidden inside. So these are the hidden facts. So this noun, modal, verb, start, end, these are all hidden facts. This is not shown to you. If a sentence is given to us, this is what is given to us. Like let us take one sentence. So if I say Jane will spot Will. Now if a new sentence is given to us and that sentence is Jane will spot Will. So what should be the tag of Jane? What should be the tag of Will? What should be the tag of spot? And what should be the tag of Will? So what we can see? We can see Jane. And then we see that what is the probability of Jane being a noun? What is the probability of Jane being a modal verb? What is the probability that Jane can be a verb and it can be start and end symbols? Right. So that's the first thing we will see. Then multiplied by, if it is in noun, then what is the probability that the next it will see is will? So again, what is the initial probability that will be a modal verb or will be a noun? And then based on that, what is the chance that it will move from noun to modal verb and then modal verb to verb and then verb to noun and so on. So we have to determine, here I have given the correct answer, but how we are going. So what is the probability? So what we are checking here is C. We are counting at the start symbol. So this should be S, not E. I'm sorry for this typos. This should be S, starting symbol. So starting symbol to Jane, what is the probability of starting symbol to a noun? And then what is the probability that from noun I have a Jane? So let's see the complete diagram here first. And if you see into this total possibilities, there are with these 3 options of noun, modal verb or verb, there will be 81 such possibilities. So the possibilities, the number of possibilities are this. So that means from modal to noun to noun to noun, then from modal to noun to noun to modal again, and then so on. So we will have
that we have discussed that n to the power t number of observations. 3 observations a year to possible number of states. If we conclude it will be 81.
So this is the problem. So how to find out the best possible options out of this 81? That's the real challenge to us. How we go ahead now? So we will do basically the Viterbi algorithm. So we use a Viterbi algorithm to determine the probability, and then this Viterbi algorithm will solve this one. So how we are going, see. So initially what we have start to say, if I consider that from start I can have three options. I can go to a noun, I can go to a modal verb, and I can go to a verb. What I have observed is Jane. So from start I can go to noun, modal verb and verb. What is the probability of going from start to verb? So start to verb is 0. Then start to modal is 1/4. So this is 1/4. So let me annotate it. I think we can annotate in this one. Annotate it. So this probability here is, in fact, this is 1/4. This is 1/4 of start to modal. You can say start to modal 1/4, and start to noun, this is 3/4. And then next observed symbol is Jane. Then what is the probability that Jane is a noun? It's 2/9. So that's written here, 2/9. Then what is the probability that Jane is a modal verb? So Jane modal verb is 0. So that's written here 0. And then Jane is a verb. So that is 0. Now you see that you have a 0 here. So 0 multiplied by 0 is 0. 1/4 multiplied by 0 is 0. And 3/4 multiplied by 2/9 is how much? It will be 1/6, hopefully. 3, 2. So 1/6. So this is the highest probability out of these three. So this one, this is 0, and this is 0. So we have three options of from start. I had three options of going to noun, to modal verb and verb. And two options, modal verb and verb, have 0, 0 values. And the third one has 1/6. So we will take the maximum one. So now we can say that from start, I am going to normally a noun in this case, because what I have observed tells me or confirms me that this is a noun. This should be a noun. Okay, so that's the first step. So next, let us go to the next one. So then here I have my total probability is 1/6. Then now again I have three options. Although these are not needed, but I am just calculating it for being complete. So from noun I can go to another noun. From noun I can go to a modal verb, and from noun I can go to a verb. Then what is the probability of going from noun to noun? So noun to noun is 1/9. Then noun to modal is 1/3. And then noun to verb is 1/9. The next observed symbol is will. So what is the probability that will can be a noun? So will can be a noun. This probability is again 1/9, which is written here. Will can be a modal verb. The probability is 3/4, and will can be a verb. That probability is 0. So again, this probability will be 0 here. This probability is 1/3 into 3/4. So this is 1/4. I hope this is clear. I am multiplying these two. This is my initial probability of the pi, and this is the transition probability. So these two are multiplied 1/4. Here I have 1/9 into 1/9. So this will give me 1/81. So now I have got again three values, 1/81, 1/4 and 0. And obviously this one is the maximum. So we'll keep this one and we can discard the other part. So we can say that Okay, similarly, if this would not have been 0, then probably I would have calculated this one also in order to keep that. So now I know that from start I had moved to noun, and then from that noun I had moved to a modal verb. And then again from this modal verb now, next. So let's start with this modal verb only because this was the highest. But I will not discard these two. I will again move on with these two also. So let's start with say noun only. So noun to this again spot. So if I consider this to be a noun, so noun to noun, what is the probability? So noun to noun is 1 by 9 again. This is 1 by 9, and this spot is a noun, has a probability of 2 by 9. Then noun to modal, this is noun to modal is 1 by 3. And spot is modal is 0. Spot modal is 0. So anyway, this will be 0. And noun to verb. So noun to verb is 1 by 9. And spot is a verb is 1 by 4. This is one sort of options. The other sort of options is, no, sorry, I will not take this one. I will only go with this last option because this is a dynamic programming technique. So I will take this option. This option had 1 by 4. So 1 by 4 into, sorry. Now what is the probability of going from this modal to noun? So modal to noun is 1 by 4. Then modal to noun is 1 by 4 and spot being modal is 2 by 9. So this probability will be 1 by 4 into, sorry, 2 by 9. 2 by 9. Then there is nothing, no change from modal to modal. So there is nothing. Then modal to verb we have. So this again is 0 basically, and this is also 0. Then modal to verb, we have modal to verb, which is 3 by 4. And spot being a verb is this one. So if you calculate this probability, this will be 3 by 16, whereas this will be basically 1 by 18. So again, this is bigger and this is the largest one. So we'll go with this one. So now I can say that I have shifted from start to noun, noun to modal, modal to verb. And similarly, if we calculate again, then verb to noun. So verb to noun, I have 1. So this probability is 1. And then verb to modal, we have 0. So this, if we consider this to be 0. And verb to verb is also 0. So there is just one option. So we'll go from this verb to noun. And then noun to end. Obviously, there is now only one option. So now I can say that what I observed, Jane, will, spot, will. So the path I found was start to noun, then noun to modal, modal to verb, and verb to noun. That means Jane is a noun, will is a modal, spot is a verb, and this will is a noun. So that's how we are deciding the tag in this case. So I think erase this. So this is what this whole table we have calculated. So this is the option. So this is the real in a clear way you can see the different probabilities what we are getting. So 3 by 4, 2 by 9, then 1 by 9, 1 by 3, and so on. This whole probabilities will be calculated. And now if you see the total number of options we have to explode out of those 1 by 81 options is quite lesser. So we had explored just, we have taken from 3 here, we have just restricted ourselves to be 1. So we have curtailed other 2 options here. We have curtailed one more option here. We have curtailed one more option here, 2 options here, and so on. Okay. Participants unmute नहीं कर सकते हैं क्या? That option is on, off. Okay. So let them unmute. So now you can unmute yourself and sorry, I could not see that you are not having that option. So someone wants to ask something?
Excuse me, sir.
Good evening,
Yes.
sir.
Yes.
Sir, actually, it is getting more complex. Like you said, every probabilities are drawn, but here are some restrictions that that maybe only modals can be used as noun can be used. Sir, then what is the chance of getting only these probabilities? Like how we can
No,
qualify
this is just an example where I am taking these three cases, three different part of speech to show you the calculation. But in reality, if we do something, it will not be restricted to three only.
Okay, okay, sir, I got it. No, I just think like it will be only like that what you have taken.
No, 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 no. This is just for demonstration. If I would have taken, say, 10 or 12 such case, say, different part of speech, then this calculation would have been very clumsy.
Yes, sir.
Hello.
So
Right,
I
sir.
have just simplified it.
Thank you,
Now
sir.
you can link it to our theory class. Just we have discussed, na?
Just a minute. Huh, no.
Just we have discussed given a state. Okay, so this is the state. Let's say Jn is a state. In that state, it could be a noun, a adverb, all those things. If I am producing a state, a particular thing, it could be a noun, it could be a adverb, it can be anything. Okay, so that is the thing. And we have calculated that jump, that state transition AIJ. That's what we are calculating, noun to noun, noun to this thing. Okay, we understood. From where we will start? That is the initial part. So we are starting from one place, ending at one place. Which path I will follow? That will depend that state transition probability. That's what it is, just an example.
Okay. There is a question. What is modal verb? So
Hmm.
modal
Good evening,
verb
sir. Can I ask?
can be. Mute कर दीजिए.
Good evening, sir.
Yes, good evening.
Sir, I just want to ask that I'm working on sentiment analysis. Now, my rule-based system is done. So, if I want to go with a machine learning, so I want to, then I need to apply the entire whatever data input data set I have. I need to apply this HMM technique and whatever now you explain. So, I need to create the dictionary for the matrix for entire thing, and then I need to calculate this for POS tagging, right, sir?
No, ma'am. You do not. In fact, the theory what I discussed, no, these are already, their tools are available. So you do not need to say create everything from scratch. Just allow me 2-3 minutes. I will just demonstrate you and say tools which you can say use to do all this sort of work.
Okay,
Just
thank you, sir.
I will be showing you the code which is already available in NLTK.
Okay, sir.
So you can do that.
Excuse me, sir.
Yes, ma'am. Yes.
Sir, I want to understand like when there is a ambiguity related with POS cost, so how we can resolve it? Like if
Please, someone is not asking, but his mic is her mic is on. Excuse me.
sir, when we have a pause type of ambiguity,
Yes, please, ma'am. Please go ahead. Okay, I'm forcing everyone to be muted, and then please unmute yourself. Pradhan ji, वहाँ से mute कर दीजिए तो सबको.
sir,
Excuse
for
me, sir.
the session,
Hello.
sir, I want to understand like what can be done for resolving the pause ambiguity. Like one word is treated as verb as well as noun. So which different techniques are available to resolve this type of ambiguity?
Say what if you say it depends. Like let me just show you the tools which are available, and then probably I will again come to you. So here you can see. Just I have a small code snippet. I'm just connecting it to my drive.
Sir, I have another question.
So you are doing this POS tagging on English language. So same concept we can apply on Hindi language also.
Yes, yes, yes.
Okay.
See here the idea is this is a probabilistic technique basically, and you can uh, take if you have sufficient example. The only thing you require is sufficient example. So if you have good number of examples, like the example what I just did had 4 sentences, and now with 4 sentences, whatever we are calculating, this is a very carefully crafted example, so that's why
Correct.
it was working well.
Correct.
But in reality, it will have a lot of other difficulties also
Hmm.
that every programmer and every researcher will naturally comes across.
Correct.
So the tags are not 100% okay. That I must say first thing. So if you require exact tagging, then probably you have to devise some other technique. You have to tweak in this thing. Otherwise, what you can do, you can use the existing tags. Like here, I am just sending you, I am just showing you in NLTK package, which I think our experts are, even myself also, I will explain you in demo session. We have NLTK package, and in NLTK package, we already have sentence tokenizer, part of speech tokenizer. Like here, you can see one example here. I have taken some sentences. I am discussing about a part of speech tagging. It is an exciting topic to discuss. I love this topic and so and so. And then I can tokenize it, and then I can find out the post tag. So in NLTK, I have a support for post tag, and you can see now it has calculated that it has given me like and is a conjunction, now is a verb, for is in, sorry, not RV is adverb, sorry. Sometimes I just confuse in this one. So this for is again some sort of proposition. Something is a noun, completely is again that adverb, different is the adjective here. Okay, so this sort of,
Sir,
yes.
I would like to ask, if I have a raw corpus of a 10,000 words, then from where I need to start for post tagging?
So that's what I am saying, that you do not need to write this sort of code and mathematics. You do not need to develop a Markov model. The only purpose of explaining this Markov model to you was that you should know the background. But tools are already available. You can see this command nltk.postTag, and you can give your text, whatever text it may be. This text I have written here, you can see that
Indian
I have
languages.
written this text. Yes,
Sir,
this
can
is
you please provide the demonstration during demonstration session for Indian language? Because I
sure,
was
sure.
suffering from a number of issues when I was considering Hindi or Marathi language for that matter.
Sir,
For
I am
Hindi,
also
I think
facing the same issue with Indian language.
so for Hindi, as far as my knowledge goes, for Hindi, post tags are available. I cannot say right now about the Marathi, what is the status of Marathi, but for Hindi, it is already available.
About
Yeah,
Gujarati?
but for using NLTK, we were suffering with
Since I
some
have not
issues.
worked on other than Hindi or English, so I cannot right now comment on the other regional languages.
Yeah, so Hindi also, if you
Hindi
can
and English,
demonstrate
I
here
know that
in
Hindi
using
exists.
Hindi, yes. So please
Hindi,
demonstrate during the demonstration session.
sure, sure. During
Yes,
demonstration, I will
thank
sure
you. Yeah,
give
yeah.
you examples
And
from
sir,
the
is there
Hindi
any
texts.
label chart for these POS labels like JJ, then RB, its meaning and then
Yes,
these
yes.
details?
It was I think in the presentation I show you know it's Pen Bank,
Yes,
Pen Tree Bank call as
Pen
this
Tree
one.
Bank. Okay, okay, sir.
Pen Tree Bank. It is.
Sir, which are the basic
This is
approaches for
available at
post tagging?
University of. Let me just find out. Slides are very badly prepared. I'm really sorry for that.
Sir, actually, sir, may I know what is
Say this one.
word
This is the meaning of.
representation?
Yes, just a
It is
minute.
from Pen
I'm
Tree
coming.
Bank. Yes, thank you.
Yes.
Thank you, sir.
So it is taken from that, and this is available on the net. You can find out, and you can have a copy of this one to you for your reference.
Hello, sir.
Okay,
Yes, sir.
someone
Thank
was
you.
asking. Sorry, I disturbed you. I stopped you in the meeting.
Yeah,
Sir,
sorry,
which
sir.
are the basic approaches for post tagging?
Basic approaches, I mean to say, you want to develop your post tag from scratch.
Basically, there are a rule-based,
Rule-based,
stochastic,
and then there
and
are
transformation.
some
So also there is a
transformation based.
supervised. supervised, unsupervised, and again there are various
No,
approaches.
this markup model is basically an unsupervised approach.
Okay, so which are basic approaches, main types.
These are the main types, but normally the first two are not used nowadays because they are not extensible. If you think of rules, you have to rules for every language, but this technique can apply to be for any language. You do not need a separate rule. The same algorithm, if you change the data set, it can give you a pos tag. This markup model can give a pos tag for every language. As the others are also told, it can be applied in a variety of scenarios.
Hello, sir.
Yes.
Here it is that pen tree bank is available. So
Mhm.
whatever the taggers are available nowadays, NLTK and other taggers are also available. So these must have used this kind of algorithm, that is HMM kind of.
Yes.
That is the meaning. Yeah. And my query is that suppose I am using this kind of tagger, I will get it ready-made. But for a specific domain, if the vocabulary is known, that is the feature space is known, so applying this HMM, is it applied today also?
Yes, yes. See, HMM is not only applied in these cases, even for clustering, like you have tags and then you want to cluster those in some specific scenario. So there also you can use this sort of HMM technique if you want to predict something. So HMM has got enough number of applications. In fact, the language model, what we will discuss in the subsequent lectures, how to check whether a sentence is correct or not. This is a tagging. Now, tagging is fine, but how to check whether a sentence is correct or not? What should be the next word which is coming into the sentence? Sometimes we see that suggestions.
Means that Grammarly
all
kind
those
of
cases
application.
we can use this sort of
You mean
models.
you mean Grammarly kind of application?
Yes, yes.
Okay. Okay, sir. Thank you.
Sir,
Yes, yes.
how we can create our own data set, like in a WordNet there are some like nouns, pronouns, syntax. How we can create the data set like WordNet?
No, say WordNet is now, people are not very much reliant on WordNet also. WordNet sort of data structures always have a problem that like they are basically restricted. Every time a new word is coming to say, a language is a live language, like Hindi is a live language. Marathi, Gujarati, all these languages are live languages. Live languages means every year these languages are having some new words coming into their vocabulary. So if someone is creating a WordNet or senti-WordNet sort of structures, one of the problem with those structures is we have to really add all those things and all those meanings. So one thing is you can always think of like WordNet and you can, but nowadays that's why people are mostly shifting towards the neural network model or deep learning model, where we do not need to maintain any such structures. We can directly write our code and do the program. So we can train the data set as and when needed.
One more thing.
Excuse me,
One
sir.
more thing.
Sir,
Yes.
how can I add this feature into a machine model?
Please repeat the question.
Stack
Your voice
feature.
is breaking down. Please repeat the question. The
Sir,
question was not audible.
Sir, as I know that POS is a feature. Okay, sir, we are doing a feature engineering. If you want to do feature engineering in NLP, then we can use a POS tag, sir. Then how can I add? I want to add this feature into a ML, any CNN type or any neural network type of algorithm. Then how can I add this feature to that? Can I convert after finding out tag?
So
How
what sort
can
of
we just convert that tag into a vector model?
Just listen my question. So what type of application you are thinking? In which sort of application you are trying to use it?
Just in if I am doing a sentimental modeling and I am trying to do some type of machine learning. Okay, sir. I want to predict with some type of machine learning, and I have a feature POS tag. I just want to add the POS tag as feature. And how can I change this POS tag into a vector model to add?
Normally,
sir.
that's what I told to that lady's question also. Now people say pause tag is not used for the if you want to learn something or predict something using machine learning, we give the whole sentence in a vectored form. It's not the pause tag. Let the machine decide what is the tag, what is the proper feature. That's the beauty of machine learning. The deep learning. If we talk about deep learning, the beauty of deep learning is allowing the machine itself to extract feature, right? So we do not do a pause tagging normally there. We give the whole sentence and then let the machine decide what is the tag or what are the features, what are the sentences, what are the words which are important, why they are important, in which sequence they are important. The machine automatically extracts everything and then it predicts something. But obviously, if you go with a machine learning and especially with sentiment structures, then in sentiment
Yes.
analysis, this adjective, adverb, these plays a very important role. So there we can highlight them. We can use them as a auxiliary information to that deep learning model. That's what we can do. Earlier, people used to consult SentiWordNet. So they used to consult, they take a word and then you go to SentiWordNet and then in SentiWordNet you can have a value, positive or negative value for every word. And then you can take that and you can use that in your sentence. But nowadays people are refraining themselves from using those sort of techniques because they are static.
Okay, sir. Okay, sir. Thank you, sir.
So, sir, POS tags are not used nowadays.
No, I'm not saying that they are not used. Anyway, if you are writing like Grammarly sort of software, there are many applications. The only application is not only machine learning based. There are so many applications like Grammarly, Quillbot, if you know, sentence rephraser. They are also a type of application where you need this pause tag and you need to check the structure of the sentence, which is correct or not. And then this pause tag gives you a good option there to find out whether the sentence is forming the grammar rules or not. Right? So that's not that they are not used. But if you say that I have a specific application of sentiment analysis, or I want to find out, summarize a sentence, then while summarizing a sentence, might be this pause tag is not needed for your application.
Sir, hello, sir. I want to thank you because you are explaining in a very good manner with examples and very good explanation. So my doubt is that can we apply after converting a text data to a vector form? Can we apply this data set to our machine learning model and WSD?
Yes, ma'am. Don't worry. We have this. This journey is going to be a bit longer. We have till 18. This journey is going to be. You are with us, hopefully. And we have. I have tried to cover each and every aspect. So a lot of questions what you are asking right now, they will be subsequently solved. We will give you the demo as well as the basic theory, sufficient theory background for all those sort of applications. Right. So please bear with us. And we will surely cover all these questions. Yes.
Sir, if I want to develop my own pause tagger from the scratch for my specific problem, then how do I start to develop my own automatic pause tagger?
You have to first collect some data, some sort of annotation you have to do manually, at least for base cases like initial probability, you have to find out. So for those initial probability, you have to consider some sort of data. You calculate your initial probability, then the transition probability based on the data sets what you have collected, and then you can write. So a lot of HMM LST algorithms are available. Even people are nowadays using LST.
Sir, I have a question.
I
How
can
to check?
share with you the HMM code also. Right now, I have to just clean it because I have not prepared it for this lecture. But I can share it with you the HMM lectures, say the codes also, which you can use as a base to develop your application. Yes, Dr. Pradhan is trying to add something.
How to check whether the
Okay, here.
POS tagging is okay or not?
First, if you want
How
to
evaluate the output?
Okay. पिला म्यूट थेरा कीजिए सर Hello. If you want to start from scratch, okay, suppose you want to model HMM, okay, so what you have to do? One way, conventional way, as I told, you have to find out, count, whether it is a noun, verb, all those things, okay, and you have to compute the probability. This is one way. Another way, you can do, you have to find out first, you have to fix how many states you have to use. Okay, 3 state or 5 state, whether it is only forward or forward to backward, everything you have to find. How many such permutation combination can be possible? Okay, given a word, next word may be, suppose this is a word, how it can be start from a silence, noun, then maybe a verb, all such permutation combination. How many such permutation? Maybe 10,000 or 5,000 such permutation combination. You have to fix it. Then suppose you are trying to model through DNA, that's neural networks and all you are saying. What will be the output of the neural network? Neural network output will be these HMM states. Okay? And given the data, okay, it will tokenize and train this model. That probability distribution, as I told, I have shown you the first slide. Na? The HMM model, what? Sir has calculated this probability because 2-3 examples. If I have such 10 lakhs example, how will calculate? Okay. So that distribution, that model to be DNA. Initially, before this DNA and all, people used to calculate that distribution using Gaussian mixture model, or you can put a vector quantizer there. Okay. This is the distribution that transition world it will learn.
Sir, we need a parallel
Once it is learned, that HMM states is the model.
Sir,
hello sir. आपका जो डाटा आएगा, now you can decode it. कौन सा स्टेट को जा रहा है?
Sir, I have created a data set.
You can Google it. DNN HMM or LSTM HMM. You can Google it. You can find that structure graph, everything, block diagram. If you Google it.
I think Bhaskar is already.
Sir, I have one question.
Sir, I have one question. I have created a data set.
I really thank. I think mute कर लीजिए उधर से.
Sir, one more question, please.
Yes, ma'am.
I have created a text data set and after converting it into a vector form, can I apply for a different neural? Can I apply it for different neural networks like AN and CNN?
Sure, ma'am. We have a class on word embedding. So there we will talk about the word embedding part in theory, and we also have a demonstration. So please bear with us for at least this week. By the end of this week, I think we have yesterday also I told that in first part, sometimes you might have some difficulties, like it's going to be a bit mathematical or something which is not very gettable, but we will be covering up that in demonstration. Everything is covered in demonstration. And in the second part, we have several examples, like use cases. The people like Dr. Siparna and Dr. Asif, they have done a lot of work. Those who work in say natural language processing, they know them, their names at least. So they have done a lot of work in summarization, document summarization, then sentiment analysis. Dr. Asif has a lot of work on sentiment analysis. How really sentiment analysis can be done. He has also agreed to give you a practical session. So I think all those things is really going to be very helpful.
And sir, I want to really thank you because you are explaining it in a very good manner. And I am personally a 9 years old.
Thanks for the compliment.
And I am.
I think yes.
I am personally a fourth standard student, and I have worked on multiple NLP projects like spam detection. And
okay, so bear with us. In the next week, from Monday onward, the things are really going to be very interesting for you. That's what I can say. So please bear this week. Next week, we will have a lot of project ideas and lot of, in fact, the projects, what they have done, they will share with you. Like we have topics on conversational AIs, like this Alexa system, how this Alexa system works, what are the emotions, how we can calculate all those things. So in NLP, now we are not only restricted to sentiment analysis and everything. Now it's a dialogue-based system. So if you say something, write something, and the other party, if the Alexa is there on the other side, and if Alexa is not understanding my emotion. And then last week, I think already there was something problem that some small kid asked Alexa that gave me some challenging problem. And Alexa asked her to jump from the balcony. So these are still the problem in our systems, what we have developed. So how to tackle those things?
Okay, sir. And one more, I have also created a chatbot which is a rule-based chatbot. I have
Good. So you ask this question to Dr. Sriparna, and I think she will be more than happy to explain to you.
Okay, sir. Thank you.
Okay. So nice talking to you.
Sir.
Yes.
Sir, previous session was also recorded session was also not uploaded. Sir, please upload that, sir.
We'll upload it. Say, actually,
Sometimes
you
it's
can
little difficult
understand. So arranging all those things, no?
Yes, sir.
It's whole day the message and the things are coming.
No,
So
sir,
we are
actually,
trying our best to upload and give everything on time. So yesterday's recordings, surely by tomorrow night, I will upload the yesterday's recording. Today's recording, I say sometimes these systems also take time to process those recording and made it available to us because this is stored in cloud. So it takes some time for us to get those optimized because videos are immediately not given. They are optimized by their system. So as soon as they are available, I will surely take care of that they are being uploaded daily. So we have already crossed the time limit. So we can take a break of 10 minutes here. And then I will request Bhaskar. I think he is already here. Bhaskar.
Yes, I'm here.
Sorry, I have taken a lot of your time.
It's okay, sir. It was a great session. We can see the feedbacks.
So
in the chat box.
Dr. Bhaskar will give you the
the
demonstration for
explanation
today.
and the example was so complimentary. It was very grateful for us to hear by you.
Okay then, thank you. See you. So I'm stopping here right now and again expecting you to join in 10 if you want to take a break. Be connected anyway. And after 10 minutes, we'll start. Bhaskar, we'll start after 10 minutes.
Okay,
And
sure.
sir, before going, I want to say that sir, this session was really good, and I want that session in that work so I can make more compliment, and also I want it in the
Recording and everything will be uploaded. Just give me some time. Okay. Thank you. So, Dr. Bhaskar, can we start?
Let's start, sir.
Okay, so let me just give a brief introduction of Dr. Bhaskar. So, Dr. Bhaskar Mandal is, no doubt, he is assistant professor in the Department of Computer Science and Engineering in NIT Patna. He has done his PhD from NIT Jamshedpur, BTech and MTech from Kalyani Government Engineering College. And he had around more than 10-12 years of experience. A lot of work he has done in the area of security and uses of NLP in data security. And he is a very dynamic one. And I hope you will really enjoy and you will have a good time with Dr. Bhaskar. So, Dr. Bhaskar, now you can start your demonstration.
Thank you, sir. Thank you. So let me share my screen. Is my screen is visible?
Still starting to share content. Now it's visible.
Now it is okay. All right. So this is a Google Colab form. I can just show you. You can say this is a simple Google Colab notebook. I have already shared this template on Canvas, as well as it is shared in the Google Drive link I had shared. So you can download it from either place and you upload this template to your Google Drive and double click on it and open with Google Colab. Okay. So automatically it will start working on your.
Sir, you are muted.
Sorry.
You was audible?
I'm audible?
Yes, sir.
Yes, sir.
Okay. Okay. So you can download this.
Sir, you are not audible.
Sir is audible.
Audible, sir.
Yes, sir.
Audible.
It's audible.
Yes, sir.
I know I am audible.
Please
Yes,
check your audio setting.
Okay. So you can please download this template from Canvas or from the Google Drive link I had shared any place. Okay, and you upload this to your own Google Drive and open it by double clicking there. Okay, open it with Google Colab. Okay, so then it will start working. Okay, so what we are going to discuss today. Okay, let me get a full screen. Okay, so we will just take small examples, small pieces of text, and we'll do the very initial requirement for NLP or text processing, like how to split this sentence in small words, then how many numbers of words and characters in the sentence, how to find that, then how to use regular expression for a different thing. There will be apostrophes. You may have seen when you see normal text or tweets or different review you collect, you will find that people used to use the short forms and the apostrophes. Okay, so how to remove them or handle them when you will use this text for your analytics. Then average length we can calculate, normalizing the case. It's always better to convert the case of the font or letters either to uppercase or lowercase. Okay, so then how to remove the stop words, removing punctuation, number of numerics, how we can find out numbers of numerics and how we can replace them by words, or if we don't want to replace, we can remove them also. All right. Then next part is tokenization. That is a very important part, and you have already seen the theory part of tokenization. Then spell correction. You will find, when you download data from say different sources, if they are review data or tweet data or social media data, mostly these data are having misspellings, right? So how we can correct them for analysis, so that due to misspell, two words or same words due to misspell should not be treated as different. Okay, so this is another thing. Then we'll go through stemming and lemmatization. Okay, but a little bit of post tagging, then advanced text processing like n-grams, then bag of words. I will show you how to calculate TF and IDF. Okay, with their formula and line by line code I will explain. And feature extraction like a bag of word. Okay, so this is a rough overview of my plan for today. So first of all, what I will do, I will import the library NLTK. Okay, import NLTK. So if you, some of you have just download, set up this collab, who have set up the collab, they can just try it. You write import NLTK and you can run it. And this text is already given there in the shared, what can I say? In what I have shared in the template. Okay, so you don't need to type this text actually. Okay, just give me a minute. Sorry. Okay. Okay, so run this. So it is taking a bit time because in a past time when you will run the Google Colab, it takes a little time. Now you can see NLTK is imported. Now I'm just running this code so that I can assign this text to a variable called text. Okay. So next target is how we can split this sentence into one. There can be different opinion from different people, right? But one of the very popular is based on the white space. If there is white space between the words, then we can use these white spaces as a separate. Yes.
Excuse me, sir. The file that you have uploaded in the canvas, sir, actually in my canvas, this content is missing. That file name is there, 13 KB file. But that code is missing, that your Python code.
How you have opened it? Where you have opened it?
In my canvas, sir. Canvas in files.
No. Have you downloaded that file?
Yes, sir. After downloading, I saved it in my drive.
Google Drive.
Yes, sir.
You have to upload on the Google Drive.
Yes, sir. I did.
Then you opened it in Colab.
Oh, yes, sir.
Have you opened it in Colab or somewhere else?
No,
some
sir.
other.
No, the Colab I have to import, no?
When you will double click on that file, it will ask you, one option will come, the open with Colab.
Okay.
Then you have to click
Actually,
on
it's the
that.
same with me.
Sir, can you
There
repeat
is no
this?
code.
Can you repeat this step? How to upload Colab in the docs?
Okay. You have downloaded it, right?
Yeah.
After that, you open your Gmail drive in a browser. Okay. Then you upload it on the Gmail drive. Once it is uploaded, you double click on it, on the file, what you have uploaded. When you will double click after that, one small pop-up will come that open with Google Colab. You click on that. I think it is worked. Okay, so let's move forward. So first thing, what I was telling you that I want to split this sentence into words. So based on the spaces, we can use the spaces as separator and we can split it, right? So it is, you can see in Python, most of the codes are very small. Okay, words equal to, so my variable name is text, right? Text dot split. Okay, so okay, so if I simply do this, we see what happens. Sorry, this is a text.
Sir, excuse me, sir. Sir, I think there are some issues with the file. There is no code there. I just opened this file using Jupyter Notebook. There is just no code in the file.
There is nothing. No, there is no code is there. Codes are not there. But
Yes, sir.
these things are there. This text are there.
Yeah, the text is there.
Yeah. Code you have to type. Na after at the end of the session, I will share the code.
Yeah.
Okay.
Okay.
So I have not given it right now so that you can type yourself. If you type yourself, then you will remember it or you will feel it, how it is working or what are the things that they are in the code. Okay. So I'm just writing words here again so that this word will print the content of words. Okay. You can write inside print also. That if as this is the last line, I'm not using that. Okay. You can write print words. Okay, now you can see the output. It is splitted based on the white spaces. And you can see everything is there. And interestingly, I can show you a few things. You can see U apostrophe is R. So it is not splitted, right? Because there was no white space. Okay. Then if you see this stop here, before the stop, we had a white space, right? So it is separated from the sentence as a word, you can say. But if you see this last stop here, it is not separated because there was no white space. All right. Now, doing this may not serve all the time our purpose of splitting the sentence. So what we can do, we can split based on word only. Okay. Or word. Okay. So for that thing, what we have to do, there is a concept called regular expression. Okay. So we have to import a package called RE. Import RE. RE stands for regular expression. I think many of you know what is regular expression. Roughly, if I say it is the pattern based on what you can recognize that what is what, right? Like say for email ID, I can tell you that it should be a string, then at the rate, then some domain name. If something you find in this format, you can say this is email ID. Okay, so you can understand, right? So this how I have described, that is nothing but regular expression I have told you. Now, anybody will come with a email ID, you can recognize, okay, it is having some string, then at the rate is there, some domain name is there after that. So it is a email ID, like that. Okay, so roughly I can just explain it in this way.
So
Now,
it is showing errors, line number 3, if you type, showing errors.
Here, I am highlighting here.
Yes, sir. Words equal to text, text dot split, print words.
Yes. Yes.
Print
I think you have
words.
not done this import NLTK at the top.
Also, I have done it. It is run successfully.
Great.
Run it.
Then you check your spelling of split.
SPLIT parenthesis.
This is a function, okay?
Oh, text dot split.
Yes.
In print words, missing parenthesis in call to print. Oh, print words.
Okay. Or you can do this simply. Only
Okay,
word
sir,
you
okay,
can
sir.
just run, it
It is
will
okay,
show
okay,
you.
sir.
But you can see what the difference. Okay, if you do it like this, it is a column. Okay, but if you print it like this, it will be printed as a row. Okay, so this is out of context for now. Okay, so first what I am doing is I'm importing the regular expression package. In Python it is named as RE. Okay, then words. So words I have used once, so that variable I'm not overwriting. I'm writing words 1 equal to RE dot. Again, I will use the same split function. Okay, but I will pass some regular expression to this. Okay, slash capital W. So in Python, writing regular expression is quite easy. Okay, so what is the capital W? Capital W is not a character, not a character. Okay, now if I give plus here, it means not a sequence of character. Understand? If you give a small w, it will represent alphanumerics, either number or character or underscore. Okay, so there is a little difference between capital W and small w. So here I have written capital W. Please mind it. Okay, comma. What I have to pass? I have to pass the sentence, that is text, right? Then I will print this words 1. All right, run this. Okay, so you can see right now what happened.
Excuse me, sir. Sir, what is the significance of regular expression here?
When you are giving capital W, it means you want to split the sentence into word based on non-character. That means wherever it will find a non-character, it will split. Understand? So if you see your apostrophe R was there, this apostrophe is not a English character, right? Or alphabet. So as this is not alphabet, it is split into U and R. Okay, understand? Then space came. Space is not also an alphabet, so it is again splitted, flying. Understand?
Sir, it is telling text is not defined.
You run this cell number 2, where text equal to you are flying on cloud number 9. This sentence is written.
Oh, okay. Okay, sir.
Sir, good evening, sir.
Good evening.
Sir, in words one equal to RE dot split within the parentheses, you mentioned a small r. What is the use for that one, sir? Small r?
This R is just to say the compiler or the Python that what is there after R is a regular expression. Okay. In this code. Yeah.
And sir, what is the significance of plus here?
Repetition. If you give only W, say
Okay.
if I am removing W and I'm running it, you will get similar result. Why? But yeah, not similar result. Yeah, in these places you have found, you know, some blank characters, right? You can see. So what this means? This means it will split whenever it will get a single non-alphabet. Understand? But if I give plus, then it will consider multiple non-alphabets. So multiple spaces are there. Okay.
Okay.
So this is happened here. You know, there is actually multiple spaces.
Understood, sir.
So it is split at 3 times. Yeah.
Okay. Thank you.
So let's move forward. So yeah, one thing I should tell you, this is a list actually. Okay, you can understand by this. You know, there is other way also, but just to show you the trick. If you don't want to, you know, print this long list of words, you can do it like this. You know, only first 10 you want to see. The number of words and character. So this is sometimes you know, nowadays it is, I don't think how much it is used, but previously it was also used in many cases as a feature. That is, how many number of words are there or characters are there in a sentence. Okay, if your sentences are very, you know, common, then it can be a feature. Okay, so usually okay, so we can simply do it like this. Word underscore count equal to, we just calculate length of how many words are there, right? So first we do a type conversion. str is the, you know, you can say type converter. We have text which is converted to simple string, Python string type. All right, so you can see in the help it is coming. If I go to click here, you can, it was coming just before. Okay, so it is by the way, it is a Python string type. Okay, so then dot split. Okay, so we want to split the string based on, say, white space. So we can give a white space here also as well. Okay, so run it. Okay, instead of no, using another cell, I'm just putting it here itself, so it will print. See, there is actually 33 words in the sentence or in the text. Okay, there is multiple sentence. I should not call it as sentence in the text.
Sir, can you please repeat this import regular expression line number 7? Actually, I couldn't follow, sir.
See, don't push me every time in the back, then it will be very hard to continue.
Oh, okay, sir.
In the end, we can discuss, because I think we will have some time in the end to, you know, come back to this code and again discuss. But as you have asked, I am telling you, this capital W here in the regular expression, capital W means not alphabet. Okay, so split wherever there is a not alphabet or non-alphabet character. Based on that, what will split? Will split text. Okay, so these two parameters we passed to this split function. Okay, so split function split sets based on non-alphabets. I think it is clear, right?
Sir, in
So-
line number 9, if I'm removing this str function, then also I'm getting this 33 as word count.
You can get, because the text is you can say it is written in 3 times quotes, so it is already string, but we write it sometimes, when we read the data from some file, other sources, it sometimes happens that text is may not be in form of string. Okay, so to avoid such errors, unexpected exceptions, we do it.
Okay, thank you.
Next, if we want to calculate the number of characters, okay, so same thing I'm putting here. Character count equal to simply length of the text, okay. Okay, so in our text there is 170 characters. Pardon?
Sir, ये dot split function got used in equation number 9. Dot split
Your
function in a
your voice is not recognizable. It is very low.
the dot split function blank
What
space
dot?
parenthesis split function
In
why
split
you
function.
in a 9
Yes. Yeah. There is nothing there. This there is no dot. Okay. See, there is no dot. Okay. It is a space I have given. So based on space, it should split it. Okay.
yes sir.
So next is how we can clean our text. So first thing will come is how we can remove apostrophes. Okay. So because if you keep them at the time of analysis, somewhere it will be written you are, somewhere it is written like this, or say should not. Some in some other sentence in the data set, it will be written as should not separately. So it will be a problem to recognize them as something. Okay, so that is one of the purpose of removing these apostrophes. Okay, so how we can remove this apostrophe? There is different ways of doing it. One of the way is by doing using regular expression. Okay. So okay, sorry, before we go for that, another issues comes, that is there is some words which are joined together. You can see pinkish blue. So it usually happens when we do tweet, comment, review, all these places. Usually we'll find it is quite common to write multiple words together like this. Okay, so how to split that? Okay, so let's see that one first, because we are already speaking about regular expression. So split attach word. So again, we need to import the RE, that is the regular expression direct package. But as I have done it here, so I'm not writing that line. Okay, so please clean text. Okay, right. Words 2. Okay. Similar variable name will help us later. Okay. Equal to, say this is a single liner, we will understand. Join RE dot find all. So here from here I can tell you, forget about this part. Okay, this part. Okay, you RE dot find all is a function which search or which finds all the occurrence of a given regular expression in the text. Clear? So in find all is a function. We will give a regular expression. Okay. So see, right now I'm not writing this R. Somebody was asking me that why this R is there. Okay. Even if I don't give R, it doesn't matter. It will also work. Sorry, I'm doing some mistake. Regular expression A to Z. If I want to write, I should write like this. In box
sir, what
bracket,
it will
A to
what it will find RE
yeah.
dot find all.
RE dot find all.
Yeah.
Yes.
What it does, sir?
See, find all is a function. Okay. It finds all appearance of a pattern in a given text or string. You can see in the help is coming here. Find all function. First parameter is pattern. Pattern means here the regular expression. Then the second parameter is string. On which string you want to find, that you give, and by default flags are 0. So we are not providing 0. Sorry, flag. So understand, flag is optional here.
Yeah, but sir, one argument you are passing there in syntax it is showing also one is by default 0, but two arguments you should pass.
I didn't understand what. See, I'm
sir,
telling you.
Pattern dot
If
string.
let me tell you. Okay. If you want to search something, you need two things first. One is what you want to search and where you want to search, correct?
Okay.
Yeah. So pattern is what you want to search, and string is the place where you are going to search. Understand?
Okay. Thank you.
Yeah.
Sir, what is
Yes,
that A hyphen Z? And
yeah.
why we are giving this in a list?
Yeah. So let me tell you. If I want to say you search for A or B or C like this or up to Z. Okay. So what it will do? It will any of them it will find. It will say yes, it is here, right? So it will be so long, right? A or B or C or D. So we write them in a compressed manner like this. A dash Z means A or B or C or up to or Z in, and we need to write it in box bracket. Clear?
Excuse me, sir. Sorry
Yes.
to interrupt. Can you share the live link where you are writing those codes? Because the Canvas link which we got the other day does not contain these codes.
The codes are not there. They only, it is a template I have shared. And after this session, I
Can
will
you
share
share
the
the
code
live
as
link, the Google Colab live link where you are writing those codes? Then we can run it ourselves.
Okay, immediately if you want to run it. Okay. I can have just a
Now
minute.
we are in the chat box, so we can run it.
I can use the chat box. Let me find if I can find the chat box here. Yeah, chat is here. Okay, so every time I'm writing, I will share it in the chat box. All right.
Yeah, it will be automatically updated, I think. You need not to share it again. Whenever we click on it, it will be automatically updated. I think so.
I don't know.
You need to share it only once.
This code I am pasting in the chat box every time. I think that will be good for you. You copy from the chat box and you can run if you don't want to type.
Yeah,
okay.
Yeah.
So then I will give a cap A to Z Okay. Then star. That means what? See, this A to Z says at least one capital alphabet should be there. And this says at least the, or this word or this pattern, what we are speaking about, must be start with, this cap means start with, sorry. Start with either of the capital letter from A to Z. Okay. And after that, you can see here I have given asterisk. Asterisk means occurrence of 0 to n number of times. Okay. So this part will satisfy if any string starting with one capital alphabet or multiple capital alphabet. Okay. If it is starting with multiple capital alphabet, then also it is going to be treated as a single word. Or okay. Understand? Yeah. So we have done this. Then we have to, that means we have given the pattern. So next thing we have to give where it will search. So give it text. Okay. Let's run this. Yeah. So I'm forgetting a bit. I need to give it here. Okay. So that it can print. Okay. So you can see here this pinkish blue. Yes.
Can you repeat it once?
Yes. Yeah. You can see this pinkish blue, these two words was together in the original text. Yeah,
Sir,
right.
I said, sir, repeat it once. Regular expressions.
Regular expression you want. Okay, this part I repeat once again.
Only split attached words, sir.
Your voice is very low actually. Let me increase volume. Now tell me.
Sir, this expression.
Yeah.
Repeat it once. How it is working.
Okay. So see this here. Let me tell you by giving a short example. If I write A to C, what does this mean? Right? It means, just a minute. What does it mean? It means A or B or C. Understand? That if I write here, instead of A to C, I write here A to J. So it goes up to R Z. Understand? So I'm telling the machine that in the pattern, there should be a letter, one capital letter. Understand? Then I was also saying that for what we are searching for, it can start with A to Z. Okay, if I forget about this asterisk, forget about this asterisk. Okay, then I'm saying that it start with one of the capital letter, but immediately it says in your mind it came. No, there can be multiple capital letter at the beginning, like say MITN. So what happens? People write MIT in capital and EN or whatever. The remaining part writes in small letter, right? So there can be word which may have multiple capital letter at the beginning, right? So how to write that? So that can be satisfied by this asterisk. So what this asterisk means? It means 0 or n number of occurrence. Understand? Of what? Whatever there just before it. Clear? So I have written the pattern. Now I'm searching this pattern in the text. And based on this, it is going to,
Is there any function that we could use to make it case insensitive?
is case sensitive, you said?
Yes, sir.
No, you have to do it using regular expressions only. You can search for function. At least in my knowledge, I don't know. Okay.
Okay, sir.
Yeah. All right. So this is one thing I have shown you. Then let's move for this removing obstacles. Okay. So for this thing, there is number of ways of doing this. Okay. So first one I'm going to do is using a dictionary. Yeah.
Sir, excuse me, sir. Sir, I'm running that line number 12, join RE.final, but the output is not showing that. When it is running, no error is showing, but output.
No error is showing. You have written in this word 2 in the second
Two
line.
might have not written.
What's 2?
Yes, words to write, words to.
Yeah, I've written.
Find all.
Yeah, then. Or you write print word 2, words 2. That will also work. Understand?
We have to write print what's 2.
Okay, so let's, sorry, here. So first thing what I am doing is using dictionary.
Excuse me, sir.
Yes.
So why did we write dot join in the?
Okay. So that will be clear if I show this. Print length of word 2. Okay, so you can see here what happened.
Sir,
it is yes.
sir,
Yes.
go ahead, sir.
You got it?
Sir, so
Every
dot
time
join
it is
is another
clicking,
command for length.
length is returning what is how many characters are there in this. That means length of the words 2 variable. Understand? So that what it is returning the length I'm printing. So this print command, print function is there. Clear?
Okay, sir.
Yeah.
Thank you, sir.
All right. So using a dictionary. So in Python, I think last demonstration you had been familiar with dictionaries as well, list dictionaries and all. So let me show you in short what is the dictionary. Okay, so I am creating. Yeah. Yeah.
So dot join is actually doing what?
See, every time it is finding something, it is joining with the
joining space in between the words.
This space, you mean?
Sir, by this way, we will not be able to complete the whole session on time because there are multiple questions from the audience. Yesterday also this happens the same and the session was left in middle.
Yeah, that is true. So
because
please, we
these
can
refer afterwards also.
Yeah. Very important questions you can ask by stopping me. Otherwise, please, in the end, we can have some discussion.
Because the important steps we will be left.
Yeah, I understand. Okay. So I'm creating a dictionary here, say appose. Okay, dictionaries are creating by putting items in curly bracket. So there is two part for each item. One part is called the key. Another part is called value of the key. You can say a corresponding value to the key. Okay, so say apostrophe is s. So if there is apostrophe s, what does it mean in your text? It is usually used for is, right? So apostrophe is s means is, like that. We can have sometimes, yeah, re, right? Re used for usually, sorry, for r. Okay, so like that it can be there. So once we have this dictionary, I'm not going to make it long right now itself. Okay, but we can use this dictionary to replace these appearances in the text by the corresponding value. Understand? This is the concept here. So sentence list equal to what we can have. We can just do word two dot split. Okay, so what will happen? It will split. Okay, so what do? Better to write text so that you will not be in confusion. Okay, because I'm writing a sentence list. So what will happen in this case? It will not. This text will be splitted. Okay. Then we create a list where we will put the new sentences or words after replacing these values, apostrophes and all. So for that, I'm just creating empty list. Okay, where we'll put it. Okay, now we'll go through each word in the sent list. Okay, actually sent list, this variable name I've given wrong. Make it word. Okay, word list. Now it will be more logical variable name. Okay, so what we will do, we will use a for loop for word in where? Word list. We are going to check each word in the word list, right? And again we will check for the whether this word belongs to this dictionary or not. Understand? Whether this word is a key in the dictionary or not. If it is a key, then we have to replace by its value, right? So for say we will replace, right? So replace in, or better you can say for key, right? Key in where? This dictionary. If any of the key in the dictionary is matching with the current word, then we have to replace it. So we'll do word equal to word dot replace. Who will replace whom? This key will be replaced by this dictionary value corresponding to that key. So call the dictionary here and put the value of key here. Okay. I think you understood what I have done. So replace the key. Key will be what? Something like this, apostrophe says, and that will be replaced by this. This is a dictionary, and this is the key. So corresponding this key here is. So it will be replaced by is. Understand? So that's the thing. Then we will just append this to new sentence. Okay, so dot append. What we are append? We are going to append this word so that it can form new sentence for us, right? So then, see, this is a list, right? You can see new sentence is list. So we have to convert this list again back to text, you can say. Okay, so we are writing here new text. So new text equal to, we need to give a space before joining and between joining of two words. So we have given space dot join. What will join? Will join these words what are there in new sentence, which is a list.
I'll meet
Understand?
you. I'm sorry, I am in another meeting. Okay.
Then
I'm
we
sorry to
can
be late.
print
No,
this
I'm
new
sorry, it's
text.
not late. Oh, thank you
Okay.
so much. Thank you. I hope I helped you. Yeah,
So
bye.
you can see this.
पागल बना के रख दिया
Yes.
है मैंने सब्र करो
Okay, I'm sorry I had to mute you all. Somebody was unnecessary speaking. Okay, so this is one way of doing it. Okay. So okay, so you are not seeing the change here, right? So okay, so I have written here you
yes
apostrophe
Saima
R,
yes
but RE. Okay, so I'm just changing it here to.
yeah it's fine but yeah tell me what were you asking
Who is this?
yeah I shared your Indian sheet
Oh my God.
which answer even I didn't fill up that form I don't know like I just share you open that
Who is
thing.
Isma? Please, you
I
mute
just opened
yourself.
that thing and I
My
shared you which was it I don't know
is showing in your name.
6:31 p.m. yeah even I didn't submit it this one
All right. So I have done this change here.
what's
How you
written
can
here
see.
it's attend okay we just have to write our name and nothing they are giving a
So you can see here you are became like this,
it's
right?
yes it's an attendance sheet
Well, who is this?
it's for today
Please give me a minute.
Isman will write your name and then write your email ID and then write today's 8 it's attendance sheet you just have to write your name and ID and no Banaras Hindu University yeah they messed up this time which option one there was nothing at such option one 0 to option 1 no it's a date open that and click on 8 Feb
Okay, so
yeah
sir,
both are same for
participants
me
को थोड़ा
also
mute
it's
करिए
same
ना.
I will share you it's an
नहीं हो
attendance
रहा.
sheet
Okay, okay, sir. Okay. Okay. So you can see here what happened. This you are, apostrophe is replaced. Then here you can see here
Not, don't be like I was busy. I told you
n
like it
apostrophe
was
T
not
is
there,
there,
no?
right? So we can just take this here and we can add to our dictionary. Say not. Okay. So run this. So you can see it is coming should not, right? So better to have a space added here. So it will come with the space, okay? So just do it. Okay, so you can see it is this apostrophe is replaced by R. Here this apostrophe N. Okay, so N apostrophe T was there, so I can add here the whole thing N apostrophe. Okay. Okay, so you can see you should not is separated, right? So this is what the replacement of apostrophe is. Okay, there is another way using regular expression. What I was telling you, right? So just a minute. Using regular expression. Okay, so what we have to do, we have to here create some phrases, okay, like phrase equal to do re dot substitute. Sub function, it means substitute. It needs minimum 2 parameters, and one parameter will be substituted by another parameter. Okay, so when I write re dot sub, it also takes a pattern. Okay, so you can see, in the health pattern, that means you already know what is pattern is the regular expression I have to write. Then replace what I want to replace, then the string with what I want to replace, right? So just try it. Say, yeah, give a regular expression again. Say in our sentence we have re, right? So we can just write here slash. This is single quote re. So if something in the sentence or in the text is matching with apostrophe re, then we want to replace that. Okay, so we'll replace it. Okay, so what will be the value? We'll replace that with r. Okay, where in send phrase here it's again. Okay, so this is the logic, but now you can ask me that why you are doing this, because I'm going to put this in a function, okay, which will do the work for us. So in Python, the functions are written like this. Def means the definition of the function, okay, then the function. What we need to pass here, we want to pass some phrase. Understand? That means one word at a time we are going to pass. Okay, we are calling it as phrase. Okay. So what this function will return? It will return the new phrase. Okay. So what I will do, say new text equal to, I call, if I call this by text, you see what happens? Okay, so in here, our original text, what we had, okay, run it once, okay, yeah. Now I just need to print it, new text, right? Okay, so you can see again, it is replaced. You know, apostrophes are, this thing is replaced by R. Okay, so simply if I want to add a space before it, so I can rewrite the phrase like this. And there is other way also. This is the simplest thing as you are doing it hard-coded thing. Okay, so now if we want to do it for this also, I have to just simply write another line. Okay, that is in abstracts, single quote, right, or abstract, yeah, abstracts you can say, T will be replaced by not, right? Now if I run this, see, we got here, should not. Okay, so this is the way how we can replace the abstracts with using regular expressions. Okay, now do some more fun things. One of the, okay, so now many of you should have a question that if this is the way, there is a huge number of abstracts possible in English, how we can handle them. If you want to do it manually, you will have to write a long code, or even you may need to, if you are using dictionary, a very big dictionary you have to write. But yeah, there is definitely a solution for it. We can just use constructions, which is a package in Python. So, sorry. Using Python library. Okay, so definitely import. What you want to import? We want to import contractions. Okay. Just let me run it and see what it is, what error it is giving. Okay, there is no module name contractions. I think there is a spelling mistake. No, it is correct. Okay, if it is saying like this, we can do another thing. We can just download. I think it may not be there. Okay, with the Colab, so I can download it here or install it here. Okay, sorry, pip install contractions. Let's see what is going to happen. Yeah. Okay, so what I have done. Okay, so I just installed it, pip install constructions. Now I import. Okay, it is imported. Now, I just need to create a new list where I will store the new sentence. So I can say expanded words equal to I empty string. Okay. Now we have to use a for loop for word in. We are using say text dot split. Okay. So previously we have already splitted many times. You can use them also, like let's see a good one. Say this one was also good split. Okay, so word one we can use, or we can use words simply. Okay, there is no modification. So in that case, we don't need to write it. Okay, I'm just commenting it. All right. So the same thing. Words we are already having a variable which holds text dot split, right? So that we can do. Okay. So just a minute. Indentation we have to maintain, otherwise it will give error. Okay. Now, what we are going to do, we are going to append every word by fixing it. Okay. So there is a function in this package, constructions package, is called fix. Okay. So we can do it like this. Expanded words dot append word constructions dot call the fix function and pass the word. Okay. Then we know what we have to do, because these expanded words are basically list of words. Correct. So we have to join them together to represent them again back as a sentence. Okay. Or if you just what I'm telling, if you just want to see this, let me show you. Okay. If I run this, you can see it is just list of words, right? So if I just want to get back the sentences, then we can just do the same thing I had done previously using join. Yeah. So I'm just copying and pasting it here. Okay. Understand? So if I run this now, so you can see it is not going to print anymore, because after this there is some new codes, other codes. In that case, it will not print anything. Okay. So this is the thing. I posted it in the chat box. You can copy the code from there. Okay. Next is, if you want to calculate average length, if you want to calculate the average length of the sentence. So I'm just using a function, writing a function, diff average. Okay, first we are going to do average word length. Okay, so what I have to pass? We have to pass some sentence, right? Then we can do one thing, that is words equal to this sentence dot place split, right? So that the sentence will be splitted into words, right? So sorry. right? We can do this. Then we know previously we have already calculated the total length. So average word length means what? The word length by the total length, right? So total length is what? Sum of length of all the words. Okay. So this equal to, sorry, there is a sum function in Python. So what we are summing up? Length of each word, right? So length function you already know. It gives you back the length of a word. Okay. So we want to iterate these words, right? So for iterating, you just write here the for loop. For word in words. Okay. So this will give basically the total length. That means summation of length of all the words. Then, okay, sorry, average word. Then we have to calculate the number of words there. Okay. So number of words equal to what? Length of words, right? It will give you the number of words. Next, what we can do? We can say we have both the values, so we can simply divide total length by number of words. It will give us average length of a word, right? So we can just return what? Total length by, sorry, number of words. Okay. Now call this function. So say average length equal to, I'm just calling this function. And what I am sending here, I'm going to send the original text. Okay. And then I will print it. Okay. So you can see the average length of the words in the sentence is this. Okay. So I pasted it in the chat box. You can check it out. Okay. Then, yeah, another important thing is removing single characters from the sentence. You know, most of the times we need to do it because numbers of by mistake we put in a single character which may not be required for analysis. Okay, so this single characters we can remove by writing some code. Okay, so remove single characters. So let's write a function here. Remove single char. We are sending the sentence here. Okay. So we do sorry, new text. So this time you can see we instead of list, I'm just taking an empty string. Okay. So by after removing this single characters, we will just create the new text by concatenating. All right. So first thing is words equal to sentence dot split, right? Then for word in words, if length of word is greater than 1, right? If it is equal to or less than 1 is not possible. If it is equal to 1, then we are going to ignore. But if it is greater than 1, then we are going to concatenate it. Okay. So if it is greater than 1, then we are concatenate these two new text. Okay. So new text will become new text equal to new text. In Python, in previous day, you have seen that class means concatenation. So I'm going to concatenate first a space, and after that space, I'm going to concatenate the word. Okay. So this for loop will give me all the words, excluding those which are having length equal to 1. Okay. So that's it. So we'll, as this is a function, we have to return. What will return? The new text will return. All right. Now let's call this, say, new text equal to this. I signed our original text. Okay, and we print the new text. So you can say cloud number 9 was there. This 9 is vanished, right? So because it was a single character one. Okay. Then at the end, I think there was some single character I had kept. If you see the original text, oh no, I had not kept here. Okay. By the way, if I keep something like B or some Z, I'm putting here. Okay. So you can see, that single character is not there anymore. After Assam, I had put it a B. So the B is removed. Okay. So this is another headache. You can say at the time of cleaning text, if you have single characters which you may need to remove, you can do it. So I pasted the code in the chat box. You can just find it. Just a minute. Okay, so next thing is, this thing we can do in a single liner also, because when we search on net for these codes, most of the time we will find that things are written in single lines. Okay, so this whole code we can write in a single line like this. Okay, this equal to, we want to have a space between every concatenation dot join. So join is kind of concatenation. It works like concatenation. Okay, you put a list here. If I put something in box bracket, it is a list. Now how this list is creating, you can see here. Say W for W in text dot split, right? And if the length of W, that is length in bracket W, is going to be greater than 1. Okay. So yeah, Python, this is the beauty of Python code. If you understand, definitely. Okay, you can see the same thing happened. Now, normalizing or convert to lowercase. So after doing all this thing, what we will need to convert everything to a particular case. Okay. Otherwise, what is the problem? Why do we need it? say in some sentence you are writing that the sky is blue. Okay, but somebody written the sky spelling here. You can see the sky spelling capital S K Y. It can be like this. Somebody can spell it like this. Somebody can spell it like this, or somebody can spell it like this. Now, if you don't make these characters or alpha, characters in the text or words in uniform case, then these will be treated as separate word or different words. Okay, and your probability distribution for these words will be just distributed among its different aliases. Okay, so we need to overcome this. So it is very simple to overcome. We just convert everything to lowercase or uppercase, whatever we like to see, basically, right? It is going to work. So let's have a function def convert to lower. So you can think that why I'm writing everything is function form. It is a good practice. Okay, if you want to reuse your code, you should write it in the function form. Anytime from any other line you can call the function and you can have it. You need not to write every time your code again and again. So I'm just writing it in a single liner. So words equal to word dot lower. So lower is the function which converts anything or any word or any string to lowercase for word in words. Okay, so yeah, this will be a list for doing this. Then it will return. What it will return? It will return this list definitely. Okay. Okay, so here I have to pass words, right? Yeah. Now our time to call this function. Okay, so we already have words previously. This variable is there, right? So we can simply write it like this. So in lower equal to. So what variable we already have? So I'm not again just creating it. All right. So you can see everything is became small, in lowercase. Okay. So I'm just putting it in the chat box as you say. Okay. Next is the text processing, that is reading the stop words. Okay, because we don't want to have the stop words in our vocabulary, because it will unnecessarily increase our vocabulary, and it will basically create some other problems also, by if it is attached to some other word, that word again going to be treated as a different word. So better to clean them up. Okay, so for doing this, first thing is that we have to import stop words. Okay, NLTK is have a list of stop words. Okay, so from NLTK dot purpose, import what stop words. All right. So if I run this, see what is going to happen. Okay. So it is imported. Okay, nice. So I can
Sir, I
create
have a
a
question.
variable. Say, yeah, sure.
Sir, for languages except English, suppose I have a different language, suppose
Yeah.
Bengali
Yeah.
or Assamese and all. So I
Yeah.
want to not depend on libraries. Like the previous tasks that you have shown, which are not really dependent on the libraries, we did it on our own. So for that case, would you please?
Many things are there. Many things are there where you may not be dependent on libraries. But you know, when you will do advanced tasks, then you will like to have some library, like you know, collection of all laptops in English. So would you like to write a dictionary of all laptops?
Yes.
Definitely no. You will like to have a library for it.
Yeah.
So like this, it depends on the tasks that whether you can simply write few lines of code and solve the problem. And instead of writing the code, if it is a big task and codes are already available, libraries are available, better to call the library, right?
Yes, yes, sir.
That is the thing.
Yes, sir. But
Like
sir, the
if
same
we look
thing,
at this,
the same task. If I'm working on text on low resource languages. So if you show the same task in a something which we don't have a library for, it will be very helpful for me then, sir.
so again, you know, I don't work on any local languages or regional languages.
Yes.
But yeah, if you can mail me separately, and if you
Okay,
give
sir.
me some overview,
Okay, sir.
some
Thank you,
overview
sir.
of your problem.
Okay, sir. Okay, sir. Okay, sir.
Yeah. So I have imported it. Now, question is that what is there, right? Many of you are thinking that what are the words are there in this list, correct? So first thing is that in the stop word, there is stop words from different languages. Okay, you can go to the help of stop words, you will find for which languages it is there. Okay, but as we are speaking about English, so I am just creating a variable stops, okay, which will, or I can say stop in English. Okay, so I have to extract the stop words for English. Okay, so stop words dot words for which language I have to write it. English, right? Next, okay, I have already imported, so let's bring this code here. Okay, ENGLIS, right? So now, if you want to see what are there in English, what are the English stop words, now we will get a predefined list. Let's run it. So what it is saying, resource, this resource stop word is not found. You import NLTK, NLTK I have already imported, and then you download stop words. So let's do it. Okay. So here I'm putting it. Let's see what is going to happen. Yeah. So you can see these are the stop word in English. Okay. If you want to say how many stop words are there, let's try. $179 stop words are there in English. All right. So let me post it in the chat box if you are using it. Okay. Now, If
Sir?
we want to count, if we want,
Sir, there
yes,
is
sir.
There is a library called Punktword Tokenizer in NHTK.
Yeah.
When I'm importing this library in Jupyter Notebook, it is not working. It is showing an error.
You look into the error, it will be written what you need to download, or some command will be given. You read the error properly, like you have seen I have done.
Okay.
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 So first, I want to count the number of stop words. Okay, in my text. So for that thing again, write Dave count stop words. What I have to pass? I have to pass sentence. Sorry. Okay. Then first thing is, if I have assigned a sentence, then we have to do this thing, right? You have to split it. Words equal to sentence dot split. Okay. Then we create a list, empty list. Okay. So all my stop words in my sentence I will store here. Now for W in words, if you want to see the word, you can print it, or you can finally print it. Depends on you. So, okay, sorry. Now you have to check that if W belongs to the stop words or not, right? So if W in, so what variable I had created here? Stop eng, right? So stop words of English. If no, W is in my stop word list, then I will list it with the okay stop. So write it my stop. I I like to give some sensible variable name. Okay. So this dot append, what it will append? It will append W. That means if this W current word from my word list, if it is common or if it belongs to the English stop word list, then we are collecting that in our my stop list. Okay. So after doing this append, we will simply we can return we can return what length of my stop, because our target is calculating number of stop words in my sentence, right? So total stops equal to this, let's send the original text. Okay, then print this, okay, total number of stops, right? So, right. So in my text, what we have, what we are using, that is having 12 stop words. So I put it as code here. You can copy it. Okay. Now, I'm just taking 1 minute to write single liner code for this. Prints. I'm just want to say I just want to print the stop words in my sentence. Okay, so say the same code can be written in a single line. Say W for W in words if not in. Okay, sorry. I'm just going to print those words which are not stop words. Okay, by removing the stop words. Okay, so I should not name it my stop. So stop removed I should write here. Stop removed. Okay, so if it is not in that stop word list, what we have, that is stop underscore eng, the English stop words, right? Now, if I run this, so okay. If you can see here, if not, then again W in stop word. Okay, sorry. Not I've written here. No issue. So I have to print this. Yeah. So you can see the stop words are, I think, being removed. U is not removed because U upstop is R is here. So you can see if I use that one, U R was splitted, right? By replacing the upstops. So what was the name of that? Let me find out from my previous things. Yeah, here we have. Okay, so let's. I just want to run this once. Okay, no, it is word. Expand word. No, it is sending different words actually.
Go to replacement.
Yeah. So this one, let me rename, say, new text 2. Okay. So I have new text 2 where okay. So instead of this, new text 2 dot split. Okay. Okay. R is removed. R is a stop word. U is not a stop word. Okay. So yeah. R is and all these things are removed. Should.
I think the issue is with the case, sir.
Yes.
The issue is with case. We have to lower case it.
Oh yeah, that can be, yeah. So yeah, let me call that function also here. So to lower, I had a function. There it is. So after doing Control D, I don't know how it will work or not. Too much of concatenation I'm doing. Yeah, U is removed. Thank you. You have noticed the correct thing. Okay, so yeah, so you have given another example that why we need to convert everything to a certain case. Okay, so okay, let me share it. All right. So then comes removing punctuations. Okay. So again, we need to import the punctuations in English language.
Hello,
Yes.
sir.
Yes, little man.
Can you show the example of remove? Can you show the example of remove punctuation using punctuation tokenizer?
Yeah, all the things are there. You know, I have more demonstrations. Okay, another 2 days I'm going to spend. So I will cover slowly. All right. So it is done. Then remove punctuation. If how we can do it again? We have some package in Python is called string. Okay. So import string. Let's see what is happening. That is worked. Now, if I just want to see what are the punctuations are there in English, right? So we just print string dot punctuation. Okay, run it. Say it is showing you the list. Okay, so when you remove punctuations, basically all these symbols will be removed from your text, right? So so we can simply write a function called remove punctuation. Okay, yes. If remove func, we are going to pass words, right? Then let's create a table. What we will put in the table? Str dot make trans. Okay, so sorry, table equal to str. Str is the object to the string class. You can see here. Str object you can see here. Okay, and detail of make trans also you can see here. Okay, so what are the things I have to pass here? Is empty, comma empty. Sorry, that means replace with empty. Okay, and string dot punctuation. That means the list I have to say, the list of punctuation I have to pass. Okay, means if it finds anything, which is which symbol is belongs to this, it will later replace. Okay, so let's stripped equal to w dot and translate. There is a easier version of doing this. Okay, but as there is a very short days of time, so I'm doing this one. Words. Okay, now return stripped. Okay, so func removed equal to, I am calling this with what I have to send. I have to send words, right? So how we can get words? Here just do words equal to this. I'm sending words here. Then print. Understand what is the benefit of what is the benefit of writing functions? You can Control C is not working. Yeah. Okay. So you can say this is the function part, and this is what some processing on the text I have done. Yes.
Sir, why the make sense method takes two empty strings instead of one? Why you have mentioned two empty strings there?
I had shown you detail. I have shown you. Here you can see what are X, what are Y and Z.
Acha. Okay.
Okay.
Thank you, sir.
Yeah. So next is number of numerics and all. This is another important thing actually. Another important thing, that is recognizing the numerics in your text. You can say here cloud number 9. This 9 is written in Word. Now, if we don't do anything with this, again it will give you problem when you will develop your model, right? Because somebody will write 9, somebody will write NINE 9. Sometimes if you are removing simply the what can I say, numerics from the text, then who have written 9 is as digit, from that text this 9 will be removed. But if somebody else have written the number but he have written NINE, in that case that is not going to be removed. Okay, so how to maintain the integrity of the or you can say synchronization of the data set? Okay, so we need to follow something. Either we convert all digit to word, say NINE like, so that it is going to solve the problem. Even if you want to remove the digits, it is not going to be removed at the time. And if somebody else have written NINE, it is going to be synchronized with the other text. Okay, so I think you understand what is the problem if there is the numerics. Okay, so first thing is that I like to count the number of numerics. Okay, so get count of say numbers. I'm passing the sentence words equal to instead of doing all this thing, I can just call all these, right? Okay, sorry. In that case, I have to put sentence here. All right. So, okay. Now we do count, a variable and set it to 0. And every time we will get a digit, we will increase this count. Okay. Now for W words, if W dot is digit. Okay, so is digit is a function which returns true if to which you have attached it, that is a digit. If the digit you can say number, because W can be 99 also, or it can be 9 also. Okay, so digits, if there is digits, it will, this is digit will return true. Okay, so if it returns true, we will just increment the count by 1. So count plus equal to 1. Okay. Then what do I do? Return it. Now, number of number equal to call this function and send your text. Okay, even you can text this text. Okay, and print. Okay, so in our text there was only one number, which is 9, so it is returning as 9. So one part we have understood, that is digit, use of is digit and finding out numbers, how to find out numbers in the text. Now our target is replacing it. Okay, yes.
Hi, sir, I wanted to know like how long will it go, because I have one meeting at 8:30. So
Okay, we are already beyond time, so I can do one thing. From here onward, actually, some very interesting things was there still remaining in the processing.
I don't want to miss it, so that is why. Can we continue tomorrow?
Can we have a session for this on Saturdays, because yesterday also something we have missed and today also.
The day after tomorrow I have a demonstration again. Okay. So day after tomorrow.
I mean, we can have one extra session on Saturday if we miss on something.
Okay, let's see. Let's see.
Okay.
Okay. These are the some basic things.
Or
Basically,
else-
IDF and
Sir,
this
or else
thing.
it is better if you please share us the Jupyter notebook file of this one, which is completed in total.
I didn't understand what you said.
Actually, what I want is the whole example. You please share us on the Google Drive so that we can practice in the app in your absence.
I understand. Okay. So some of the things I will definitely, which does not need my help, that I will definitely share with you. Okay.
Yeah, even the things which you have not completed, if you are having that one, you please also share that.
All right. All right. Okay.
Thank you.
Sir,
So are we continuing tomorrow now?
Okay, so I think Bhaskar, we can stop for today. We can say goodbye to, thank to all of them. In fact, so they are still there at around 8:30 right now. The time is, but it's good to see a lot of participants still hanging out there, still communicating and taking an interest in this one. We'll continue. Daily we have a demonstration session and in fact practical session. So let us stop here today.
Sir,
Yes.
Can you take my down? Sir.
Yes.
I want to tokenize my sentence using word-punct tokenizer, but when I am importing the word-punct tokenizer, it is showing me the error. Cannot import punct tokenizer, punct word tokenizer from.
You do NLTK. Just listen. You do NLTK dot download in bracket punct PUNCT.
Yes.
Punctuation symbols you have to download on your system.
Okay, sir. Thank you.
Okay, NLTK dot download in bracket punct. Similarly, NLTK dot download in bracket stopwords. So you download this one, and then only it will look after
Excuse me,
anything
sir.
to that, and it will do the tokenization.
Sir, can you please show some demonstration for Hindi language using NLTK?
Okay, right now we do not have that, but obviously next week, because that also we need to gather the data set and prepare model. Immediately I cannot show you, no. So obviously I will target that next week, next Monday, from next Monday we will surely put on some. So please wait for this week.
Okay, sir.
We need to
Okay.
collect.
Sir,
Let
please
us
share
collect and
this
then share.
code. Bhaskar sir, I have one query. Can I
Yes.
ask?
Yeah, sure, sure.
Sir, you explained about contraction library. So actually, I'm using my Jupyter notebook. So when I'm installing my this contraction in my Jupyter notebook, I'm getting error. Means I'm unable to install the library here.
You have to install it. You write pip install NLTK
Yes.
dot constructions. I think
Yes,
so.
yes, same command I'm writing here, but I'm getting error here. With error, something is coming.
What is
Finish
the
with
error?
What kind of error?
some long error is coming, sir. I'm
So you
pasting.
have to tell that error, no? Then only we can suggest.
Error is something
It
command
may be,
errored out with exit status 1. It's a long error, sir.
it may be
There in chat.
you are not running with admin mode. It can be without seeing.
Is it the Anaconda you have installed?
Yes, yes, sir. Anaconda I have installed.
With Anaconda, sometimes there may be some unique, peculiar problems.
There
So
are some.
that can
Sir,
be with
there are
environmental
certain.
problem in Anaconda.
No, there are
That can
certain
be one issue.
compatibility issues, sir.
Yes,
Compatibility issues
Anaconda there are
in
certain
Anaconda.
issues.
Okay.
Yes.
So one thing you can do instead of Anaconda, you can uninstall the Anaconda and you can now afresh install all this, say Python and then LLTK, and then try once. Because say in research and this sort of experimental setup, you have to sometimes you have to do all this sort of things. That's what I can say without looking at your code. Because I have already encountered so many problems with the Anaconda system.
Okay. Sir, I've pasted my error in the chat window. It's a long error actually.
So error is running. So you have a problem of Visual C++ something? All these visual environments are ready?
Yes, sir. Yes.
What I can understand from this running BDS building, error is Microsoft Visual C++. So you first try to update your Visual C++ version. VC++ from Microsoft site, you download it and try to update it once.
Okay, I'll try, sir. Okay.
Might be it is using some feature which is not there on your system.
Okay.
Okay.
Okay. Okay. Thank you, sir.
Okay, so thank you. Thank you, everyone.
Thank you, sir.
Yes, sir.
Thank you and good night to everyone. See you tomorrow.
Teacher,
Thank you, sir.
Sir,
Yes.
in INLTK package, if is Hindi language is there in INLTK language library?
Yes, Hindi is there. In NLTK, there is a support of 13, 14 languages.
Marathi, teacher?
Marathi, I'm not sure. I have not seen. So I cannot
Marathi
comment
also
right
is
now.
there, sir, but then how to use it, that is the major problem.
Okay.
Because if
I've
we
not
use this
worked on
tokenize
that
and sentence tokenize everything, na, so it gives error. If we type the text in Marathi, means
So
if
the
we use
problem
the
is,
Hindi.
have you used Unicode? Unicode. Because with
Yes,
Hindi
we
also,
have tried.
it will not
That's
be.
why we have requested, sir, to you.
So one of the major problem is with Unicode standard, because these languages will be represented in Unicode. Sometimes UTF-16 and other higher encoding versions.
Yes.
Which
But
is
then
not
is there
represented
any
in
need for special setting up of that? So that we are
Yes, in
unaware.
the code itself, you can write /u dot u comma, then that will take it as Unicode.
Sir, what is the difference between UTF-8 and UTF-16, and why should we always use UTF-8?
No, it's not mandatory that you have to use UTF-8 only. UTF means how many bits you are using to represent your characters. Like if it is say 8-bit, you can represent 250. Yes, 8-bit 256 characters you can represent. Like in Hindi, in English we have 26 characters in uppercase, lowercase, plus some punctuation symbol. So ASCII was sufficient, which was of 7-bit. Then we move on to ASCII Unicode, which is 8-bit. And now Chinese characters, that they have infinite vocabulary. Infinite number of words are there. So even 16 will be lesser for them. Okay. So that's
Thank
the
you
problem.
very much.
Sir, please share this
Okay.
file link in WhatsApp group, sir.
Okay, sure, we will share. So say, we'll stop here. Good night, Bhaskar.
Thank you,
Please
sir.
share this.
Good night. Good night,
Thank you so
everybody.
much, sir.
Okay. Bye. Good night.